Awesome. You've done fantastically to get this far. And for this section, before we get started, actually moving over to Hardhead and moving over to JavaScript and understanding why we need to do that, let's understand a little bit about getting help and running into problems. So let's say we have our FundMe contract here that we just worked on, and we run into an error. Let's say, for example, we forgot the payable keyword, right? And we go ahead and compile this. We'll compile fundme.sol. And we scroll down and we see, obviously, we have two errors here, right? We're getting some errors. And we scroll down and we see type error, message.value, and call value can only be used in payable public functions. Make the function payable or use an internal function to avoid this error. And then it goes ahead and gives the line that's erroring. Now, this error is pretty clear. This error code is pretty clear. It's saying, hey, make the function payable or use an internal function to avoid this error, right? This should be pretty easy to add payable and then recompile and be good to go. And this is actually a good example of what to do when you run into errors. When you run into errors, the first thing you want to do is you want to try to figure out exactly what's going on yourself based off of what the error says. This one's pretty straightforward, but some of them can be a little bit more obscure. Step one, when trying to get unblocked, trying to tinker and figure out errors yourself, right? Because maybe you go, okay, I'll make this payable, right? And you go to save, and then it gives you a different error. It's saying, hey, payable doesn't go here. You resave, you recompile, it goes, hey, we're still missing that payable thing. First step is always going to be try to tinker and figure it out yourself. For this course, I want you to limit tinkering/triaging to 20 minutes. If you take more than 20 minutes to tinker and triage, then move on to the next step. But I also want you to take at least 15 minutes yourself, or be 100% sure you exhausted all options. You're completely out of ideas. So typically try to tinker, try some stuff for 15 minutes. And if you're under 15 minutes and you're saying, hey, I'm 100% certain I've tried everything that I can think of, then you can move on to the next step. So step one, when you run into errors, is always going to be tinker and try to pinpoint exactly what's going on. Try to pinpoint exactly what's going wrong. Step two, let's say you tinkered and you tried payable all over the place and you couldn't figure out what this error was and how to debug this error. Step two is always going to be Google the exact error and see if you can learn from that. So I'll zoom out a little bit. I'll roll my mouse over this. I'll grab this. I'll copy it, put quotes around it, and do exactly that. And Google search that exact error. And take some time going through Google, going through Stack Overflow, going through Stack Exchange ETH, and look to see if somebody has asked this question already. And it looks like down here, it looks like somebody has. Type error, message of value, and call value can only be used on payable public functions. And if we scroll down, we see that somebody ran into exactly this, and they went ahead and solved it. They go, I realized my mistake. I needed to add the payable keyword to my own implementation. And they go ahead, in this question, they've added the payable. And hopefully this would give you the insight to say, okay, great. I do need to come back here and add payable. Let's say this Stack Overflow question didn't show up, right? This form wasn't here. What do we do next? So step one, tinker. Step two, Google the exact error. I'm going to do a step 2.5 that only is for this class. Go to our GitHub repo discussions and or updates. For this course specifically, go to this GitHub repo, full blockchain solidity course.js. It'll look a little bit different when you all get to it, but come to this repo and look in this chronological updates section to see if there's an update on that section that you're doing. Obviously, since I'm recording right now, there's no update. And if you don't get anything, feel free to jump into the discussion section and ask a question in here, right? There's going to be a community of people looking to help each other out and looking to, make this a lot of fun. And the reason I say 2.5 is because in the real world, you're not going to have our GitHub repo. When working on stuff outside of this course, you're not going to have this GitHub repo. So instead, in the real world, I'm still going to give you the keys. I'm going to give you what it takes to still unblock yourself on anything, okay? So number 3 is going to be to ask a question on a forum like Stack Exchange ETH and Stack Overflow. Stack Overflow is a question and answering tech forum like this, right? You can ask tech questions and then you can answer them as well. And as you can see, when you search for these issues, they'll show up. So Stack Overflow is more for general programming questions, and Stack Exchange Ethereum or Stack Exchange ETH, the Ethereum Stack Exchange. This is for more Ethereum or EVM based question, and all the Solidity code that we're going to be working with, whether it's Polygon, whether it's Avalanche, whether it's whatever, those questions are going to be valid here and you can ask here. So what you'd want to do is you'd want to sign up or log in and ask and format your questions on these forums. You'll want to sign up for GitHub. You'll want to sign up for Stack Exchange ETH. You'll want to sign up for Stack Overflow so you can participate in these forums. In fact, if you haven't already, let's sign up for GitHub right now and let me walk you through formatting one of these questions, because the better you format your questions, the better chance you have of actually getting the answer. And remember, when asking questions on these forums, when asking questions in these discussion communities, people answer these questions out of the goodness of their heart, right? So if you don't get a response, there's a chance that maybe nobody knows, maybe your question isn't formatted very well, and etc. So we're going to learn how to ask really good questions here. And if you're new to blockchain, do not skip this section, okay? This is going to be that piece that's going to give you the superpower to unblock yourself from any coding issue you run into. So don't skip this part. Be sure to follow along. Okay. So if you don't have a GitHub already, you do need an email to get started. So I'm going to go ahead and sign in. I made a burner account just for this video. So what we're going to do, we're going to go ahead and sign up. GitHub, enter your email. And we hit create account. They're going to send us an email. So we're going to come back to our email. We're going to get our launch code here, paste it in, answer a little bit of information. We're going to choose the free version. And fantastic. We've now created a GitHub profile. Now, back over in the Smart Contract Kit full blockchain Solidity course.js, I'm going to create a new discussion, a new thread that I want you all to comment on to make sure you understand how to format and how to ask questions, okay? General thread for practicing question formatting. Woo! And so let's go back here. So first, I'm going to format this question poorly 2 ways, and then we're going to format it really, really well. So the first way we're going to format it poorly is by not giving enough information. So what we're going to do is I'm going to just copy this issue. What we're going to do is we would just say like, hey, I'm having trouble with remix and an error. Can someone help me? Why is this not a well-formatted question? If this is my question, there's not nearly enough information here. I, as a helper, have no idea what this person's asking. So let's do something else. What I'm going to do is I'm going to copy this entire contract, all of fundme.sol, paste it in here, and go, hi, I'm having issues here. Can someone help? And I'm going to hit start discussion. Here, when I hit start discussion, it formats this all weird. And once again, there's not really enough information here. I don't know what the issue is. But at least with this one, we have some code. We have some way to actually debug. So this is a little bit better, but it's still not that good. Let's go ahead and edit this to make this even better. We can hit 3 dots. We can hit edit. What we can do is we can use something called Markdown syntax. And I highly recommend learning a little bit of Markdown. It's basically some syntax to help make discussions on GitHub and then also questions on Stack Overflow and Stack Exchange a lot easier. So we're going to format this code by adding these 3 backticks at the start and then also at the end of our code. And then additionally, next to the first 3 backticks, we're going to type solidity, which tells the formatter to use Solidity to format this code here. Now, if we update discussion, we notice we get some nice highlighting here so that this becomes much, much easier to read, right? This is way easier to read now than it was before. However, it's still not specific enough. We've given a ton of code here and we haven't given the specific answer. So this is going to be really hard for somebody to answer. So let's make this more specific. So let's edit this question again and let's specify. So we see here, our issue is specifically on this function. So we're going to copy this function and we're going to delete everything else in here. And now we have just this code inside of here. And now we're going to make this really specific. We're going to say, on this function, I'm running into an error. And then what we're going to do is we're going to come back here. We're going to roll over this. We're going to copy this. We could have pull error code if we want, but we're going to format this error like this. And then we're going to say, can someone tell me what's going on? update. Now, this is a much, much easier question to debug, right? We have some minimalistic code. We have the error that we're getting, and we have, can someone tell me what's going on? Obviously, the answer to this would be to add payable to this. And that's what somebody would say, hey, like you need to add payable to this. I want you all to practice doing some formatting. Go ahead and add a comment on this with your own formatted question so that you understand how to actually do the formatting. And it's this markdown format, it's this format here that's going to be the exact same for asking questions on Stack Overflow or Stack Exchange ETH. For this course, go ahead and practice. If you want to create more new discussions, feel free to create new discussions. If you want to use Stack Overflow or Stack Exchange ETH, I actually highly recommend you use Stack Overflow or Stack Exchange ETH as well, because those are going to get indexed a lot better than GitHub here. However, feel free to ask questions, obviously, in this GitHub as well. Now that I've given you kind of the basics rundown, we're going to watch a video that I made that goes even deeper into why and how to format all these questions and what to use. So let's go ahead and watch that.
Every developer has run into this. Something breaks, or maybe you don't know something, but you don't have time to let these stop you. There are a series of steps that one should take to maximize one's chances of solving any coding problem. But you'd be surprised at how few developers currently use this superpower effectively. Our first one we'll spend the least time on, because it's just tinker and experiment. When you run into an issue, keep trying different things you think might work. Maybe try doing print statements throughout the file, learn some debugging tips, but don't be so cocky that you only do this first step.
And this shouldn't just be random running around. This should be trying to pinpoint exactly what's going wrong in your code so that you can either ask an effective question or figure it out yourself. So pinpoint exactly what's going wrong, because you'll need it for the next steps anyways.
Next, check the documentation. Not all tools have good documentation, but taking some time to explore documentation can be a quick way to find your answer. You'll want to learn how to search a web page with Command F or Control F. That way you can look for specific keywords on a page, or hopefully they have a good search bar that works well. Sometimes documentation can be really dense, so maybe you'll move to the next step, which is doing a web search. At the end of the day, good software engineers are secretly just professional Googlers. And this is one of their most powerful tools, being able to search the web for somebody else who has already run into the problem that you've just run into and then solved it. Most search engines, like Google, have tools you can use to get even more specific about what you're looking for. Often, for specific errors, the best thing to do is actually just copy the exact error and paste it into the search bar with quotes, or use the asterisk in spots your error might be too specific. Most of the results you'll get will be from forums and Q&A sites, which leads us to our next step, asking questions in these forums and Q&A sites.
Just make sure that before you ask a question, you've done some ample Googling around yourself beforehand. This way, you don't waste yours and anybody else's time. And by asking questions, you swear, you will promise me that at some point you will go back and help other people learn as well. Got it? Good.
Before even asking your question, though, we should learn where is going to be the best place to ask this. And this is why I've categorized 4 different types of forums and QA sites. Feel free to pause to read them over. And here are some specific examples of each one of these. Indexed code-based forums like Stack Overflow, indexed repositories like GitHub issues, indexed technology-specific forums like r/ethdev, or unindexed discussion platforms like a Chainlink Discord. One of the key differentiators in these categories is the indexed keyword. We typically want to ask questions on forums that web crawlers have gone through and stuck them in their database or indexed them. This way, in 3 weeks, when we look back at the code that we wrote, we can just Google what the is going on when we forget what it does. And this will help out other developers who run into the same problem, which in turn, they might go ahead and help you out later. Ideally, most of your questions should be asked on one of these indexed forums for this reason, for their searchability and discoverability. However, some questions are better fit for DMs, Twitter, or Discord that aren't indexed, and we made a little chart here to figure out where's the best place to post your questions. Feel free to pause the video, take a look, or read our blog in the descriptions with the picture as well to take another look at it. And of course, before actually posting to any one of these forums, be sure to read their rules, as they might state that some kind of questions are specifically forbidden, but basically the breakdown looks like this. Theoretical, big picture, or opinionated questions can go great on general Q&A forums like Quora, or specific technical forums like specific subreddits or Discord forums. Specific coding questions can go on these forums as well, but will often get more eyes on coding forums like Stack Overflow or Stack Exchange communities. Often the question of, oh, should I post this on Stack Overflow or maybe a Stack Exchange community is incredibly blurry, and sometimes it doesn't really matter which one you post on. Now, if you run into a bug or an issue with a technology you're really familiar with and you think it shouldn't be breaking, this is your chance to pop an issue into their open source code repository and potentially improve the tool. If they don't have an open source code repository, you throw that closed source piece of shit into the garbage. Just kidding. Closed source tech has its place in our lives too. Additionally, if you're following a tutorial and they have a Git repo associated with it, like all of my videos that do, that's going to be the best place to leave your issues. So as much as I hate to say it, putting your issues onto my GitHub repositories is going to be much more effective for us answering your questions than posting it in the YouTube comments. Now, finally, Discord, Element, email, text message, or any other of these unindexed chats are still good places to ask questions, but please try to use them as a last resort. And if they do end up answering one of your questions, maybe go back and add that question and answer to one of the other forums that we were talking about. This way, it will be indexed next time you or somebody else Googles it. Now, these quicker chat forums are places more for the community to congregate and have quick conversations with each other. They're places to theory craft, talk about new things coming out, new ideas, events, and other things that shouldn't be indexed by web crawlers. They're also great places to meet and network with people that you might be able to bounce ideas off directly as you get to know each other, which leads into our last section. But before we do that, uh-oh, do you hear that? Oh, that's the video inside another video alarm ringing. When you ask a question in one of these forums, the better you format your questions, the better chance you'll have of getting it answered. Now, there's no bad questions out there, but there are poorly formatted questions. So let's teach you how to always ask questions as formatted as best as possible to give you the highest chance of making sure they get answered. Number one, before asking your question, make sure you followed all the steps in the parent video and you've done some research on this already, and make sure the question hasn't already been asked. Number two, make a title that summarizes the specifics of the question. 3, introduce the problem before you write any code. Add minimalistic, reproducible code. Minimalistic code means it's not just a copy paste to your entire file. If you're having problems on one line, maybe just post that one line. Reproducible code means that others should be able to run into the exact same error that you're running into, or at least post the steps for them to do it. This doesn't mean that you should put, I was following along Patrick's video and on hour 5, I ran into this problem. Just watch his video and you'll get there. As flattering as this is, it's not reasonable that everyone is going to have watched my videos, even though they should. You'll want to give the technical steps to reach the error that you've reached. For those of you watching my free code camp video, you're kind of exempt from this, but you can only say, hey, I was on hour 5 on this part of your video inside of our discussions tab of the GitHub repo associated with this course. So you can do that, but only in that GitHub repo associated with this course. Learning Markdown to format your code, especially using these 3 backticks and labeling of the language. This is a critical piece of formatting your code and will drastically improve on the number of people who answer your questions. Any errors or code should be formatted with this 3 backtick syntax. And finally, often people who care about certain technologies monitor specific tags and monitor specific questions being asked about the technologies that they like. And then finally, again, be sure to read the forum's guides before posting. Different forums have different rules about what they want and what they don't want. So being familiar will increase your chances of getting an answer. All right, so now back to the main video. Now a note about Stack Overflow in particular. Stack Overflow can be a little aggressive, which is why sometimes posting on specific community forums might be better for your specific technology questions. If you post on Stack Overflow and you get a ton of downvotes on your questions, don't let that bother you. Just take it as a learning opportunity to learn about what Stack Overflow likes and doesn't like, and just keep going. But do not let that discourage you. Okay, well, now that we know where things should go, where questions should go, and how to actually format them, let's practice. Let's look at some sample questions that you might have, and we'll figure out where we want to put them. So this first one, where does this one go? Feel free to pause and guess yourself. So a question like this is going to be great for a Reddit or a Discord. Probably more a Discord. Now, this is definitely something that you can search for, right? So you probably could search for this, find an answer, and go from there. But maybe you want to ask a buddy, or maybe you want to ask a very specific community like r/ethdev. Now, of course, if you see this question, you obviously want to recommend Patrick Collins' YouTube channel. Now, how about this question? Notice it's formatting, right? The title is nice and big. They have a technical command that is formatted properly. They have git commit, which is formatted properly. Where would this go? Something like this would definitely do very well on a Stack Overflow or an indexed code-based forum. They're very clearly trying to do something technical. Their problem is laid out very clearly, and they've given the command that they're looking to do. Now, how about this one? Something like this could go on either Stack Overflow, but it's probably more likely going to go on a GitHub issue for this Brownie package. A big difference between code forums and in Git repos like GitHub is that when you make an issue on a GitHub repository, especially when you think there's a problem, you do want to be as in-depth as possible. So oftentimes when making an issue on these repos, they'll even ask, what version are you using? Can you post all your code? Can you post all your files? And just be much, much more explicit. So now how about something like this? So this is going to be really good for the GitHub repo associated with this tutorial. It looks like this person is asking about a very specific tutorial. So posting this there is going to be best. Now, if your question is on a tutorial that doesn't have a GitHub repo, well, they probably should, but then maybe this is better in the comment section. Now, again, this is where this all becomes a little bit more art than science, because maybe this specific error that they're running into is a generic error that a ton of people run into, and maybe it is better on Stack Overflow, or maybe there's an issue with the package, so maybe it is better on GitHub, or maybe the solution to this is opinionated. And finally, what about this? Yep, this is going to be much better for a Discord or a DM with your buddy. Anyways, our last step on unblocking you from any question is going to be join and strengthen the community of your tool. Now, at the start, it's going to be hard for you to give back since you're not going to be very knowledgeable on these tools. But as you get better at these technologies, you'll want to try to answer some of these new questions that do come in. The reason is because this will give you a chance to actually learn more about the tools that you like. It'll strengthen the community of your favorite tools, meaning if you help answer questions in a tool, it'll actually encourage other people to use the tool because there's a strong following there, and likely they might actually help you sometime in the future. You helping people will make you look like a good person, and then you'll also feel like a good person. Additionally, in many forums like Reddit, oftentimes mods will actually look at how often you post versus how often you help others and comment on other people's posts. And some mods may actually start blocking your posts for abusing the forums and not giving back to the community and only trying to take knowledge. You and the community will be more successful if you join in and help others and not just try to extract things from other people. Additionally, by engaging with the community, I can't tell you how many people I've met and I've learned and been able to brainstorm with. And then the final step is going to be iterate through these steps. Maybe you get to the end of these and you say, oh, I'm still blocked, but you'll likely be much, much more knowledgeable. So you want to go back and try these steps again. Now, this is where this whole process is a little bit more art than science, because some questions might not have been discovered yet. Only very few people know. Not enough people understand the importance of the questions, or maybe people don't understand your question. And this is why it's important to go back and iterate on these steps. Now that you have the basic building blocks of this incredible superpower, I encourage all of you to go out there and try this and then let me know how it went.
All right, awesome. So now that we know more about how to get unblocked, we can move on. The reason it's so important to learn how to get unblocked is because blockchain and Web3 is more than just everybody on their own. It is a very collaborative space. So as you get better and as you learn more, a massive way to test how much you've learned and give back to the community is going to Stack Overflow and going to Stack Exchange Ethereum and trying to answer some questions yourself. So I highly recommend you all go to Stack Overflow and then you go to the GitHub repo associated with this course. You try to answer some discussions, try to answer some issues, and help other people out because it's going to help you become a much better software engineer. The other reason I wanted to do that part is because when we install some of the tools that I'm about to show you, sometimes the installation process is the hardest piece there. Once you get past the install process, it generally becomes much, much easier. But this can often be the hardest part of the course, is just installing some of these tools that we're going to give you. And that's what we're going to learn about right now. So we have been working so far with Remix. Remix IDE, or Integrated Development Environment. As we've seen, it's this wonderful place where we can try out code, we can try Solidity out, we can compile, we can deploy, we can pretty much do everything that we need to do. It's web-based, it can do testing, debugging, deploying, local JavaScript VM. It's very quick and easy to create and test our smart contracts. However, it does have some limitations. It can really only deal with smart contracts. It can't really integrate with other parts of projects. Has limited support for test or custom deployments, and you need an internet connection to even work with Remix. And it can be tricky to do a lot more advanced functionality. So it's a phenomenal tool, and absolutely, if you're looking to do something very quickly, I absolutely recommend everybody just go to Remix to go ahead and try something out. However, now we're going to move over to a more professional smart contract developer setup, and this is with Hardhat. This is known as a smart contract developer framework, similar to Brownie or Foundry and the likes. There's a number of these frameworks, and the reason that we're going to do Hardhat is because Hardhat is JavaScript based. It's a JavaScript based development environment. It's got JavaScript based compilation environment, deploying, testing, debugging. Now, for those of you who love TypeScript, we will also have TypeScript editions of every single one of our code examples for you. So if you love JavaScript, we got you. If you love TypeScript, we also got you. We're not always going to walk through us doing the TypeScript, but we will sometimes. And all of the code for the TypeScript will be available in the GitHub repo. Now, before we can actually learn Hardhat, we have to learn another package first. So we're going to learn how to do everything with Ethers.js, which is a JavaScript-based library for working with smart contracts. And it's also what powers the next tool that we're going to be working with, which is Hardhat. Under the hood of Hardhat, there's a lot of Ethers.js. So it's important for us to learn Ethers.js so that we can understand what Hardhat is actually doing. Now, for the rest of the course, I'm going to be using a code editor called Visual Studio Code. This is one of the most powerful code editors on the planet. And if you've already got it set up, feel free to go ahead and skip this part. If you already have a professional coding setup with Node.js and VS Code and Git and everything, feel free to use the timestamps in the GitHub repository to skip over this setup section. You'll often hear people refer to this as VS Code or Visual Studio Code or just Visual Studio. However, it's important to note that Visual Studio Code, this is different than Visual Studio, which you might see look like this. So Visual Studio Code is what you want, not Visual Studio. Visual Studio is a different application. Make sure you're on Visual Studio Code. Now, if you choose so and you're a total hardo, you can absolutely work just with your terminal or just with PowerShell or just with whatever coding environment that you want, like Atom or Sublime. However, for us, we're going to be working with Visual Studio Code. And I'm going to be going through setting up Visual Studio Code the way that I like to set it up. You can absolutely set it up whatever way that you feel comfortable. And of course, in our lesson 6 here, we have a link to installation and setup, and I'm going to be adding more links as we go about here. And once again, all the code that we're going to be working with is in this GitHub repository down here where it says code. Now we're going to go through 3 different installation processes and pick the one that's most appropriate for you. The first one is going to be for Mac and Linux users. The second one is going to be for Windows users. And then our third one is going to be a last ditch effort. If for whatever reason you can't get Windows or Linux or the Mac instructions to work, we're going to use a Gitpod installation. Now, I highly recommend that you try to get everything working locally without using Gitpod. However, if for whatever reason you can't get those installation pieces to work, we will have Gitpod instructions for all of the repos that we work with here. But to get started, we'll start with the Mac and Linux installation instructions. The first thing you're going to want to do is download the Mac, or if you're working with Linux, download the Linux installation of Visual Studio Code. Once you have it installed, it'll look a little something like this. And if it's a fresh installation, it'll even give you some tips and tools to actually get started. If you've never worked with Visual Studio Code before, I highly recommend going through any get started or getting instructions tips that come with opening Visual Studio Code. Additionally, we have a Visual Studio Code crash course in the GitHub repo associated with this course. Once you have Visual Studio Code installed, the next thing that we're going to want to install is going to be Node.js. And again, we have links to all of these in the GitHub repo associated with this course. You can just go ahead and click download for macOS or download for Linux. I recommend using the LTS version. LTS stands for long-term support, which means that they will be supporting this version for a long time. So go ahead and download Node.js. I've already downloaded this, so I'm not going to go ahead and re-download this. Now, one of the awesome things about Visual Studio Code is it has this thing called terminals, which are command line prompts that allow us to run scripts. Basically, it's where we're going to be running all of our code. The way we can open up the terminal is we can go ahead and hit terminal and select new terminal. And you'll get something like this. Now you might have bash or ZCH or some other type of shell. The type that you have doesn't really matter because on Mac and Linux, it's going to be Linux based. We can now test our Node.js installation has been done correctly by running node --version. And you should see something that looks like this. The exact version of Node that you have doesn't really matter here, but ideally you're at least on Node version 14 or higher. And if something like this doesn't show up, remember to go ahead and start looking on Stack Overflow, looking on the GitHub repo in the discussions tab, looking on the updated section, etc. And like I said, sometimes installing this can be the hardest part of this entire course. So don't get discouraged, and please use Stack Overflow, Stack Exchange Ethereum, and the GitHub repo to move past any issues you run into. Now, if you're on Mac or Linux, you can actually hit Control backtick to actually toggle your terminal mode. This will pull the terminal up and down for you. Getting familiar with keyboard shortcuts will actually make your life a lot easier because you'll be able to move around Visual Studio Code much more effectively. We have a link to a list of keyboard shortcuts additionally in the GitHub repository associated with this section. As we move along, I'll give tips on different keyboard shortcuts that you can optionally use. Otherwise, you can just go ahead and click as well. You can click the trash can to delete the terminal, go back up, terminal, new terminal to pop it back up. Now, the next thing that we're going to need a little bit later, we're not going to need it for this section, but it's good to install it now, is going to be Git. Node.js is known as a JavaScript runtime, and it's a tool that we're going to use to help run JavaScript code in our Visual Studio Code. It's not exactly JavaScript, and the difference between Node.js and JavaScript can be a little bit confusing, but don't let that stop you for now. Next, we're actually going to go ahead and install Git. We will have links to the installation instructions in the GitHub repository. Installing Git on Linux, you're going to use one of these two commands. And on Mac OS, if you just type Git on the command line, it should go ahead and prompt you to install it. So if we're back in our command line and we just type Git, it should prompt you to go ahead and install it. And if you do git -- version, you should get something that looks like this. You can also use a macOS Git installer by clicking this link here and running through the installation process. All right, now that you have Node.js, Git, and Visual Studio Code installed, we can continue on to the next section. Awesome. If you're not planning on using Windows or Gitpod, feel free to skip the next two sections. I'm running this on Windows 11. However, it should work on most editions of Windows. So the first thing that we're going to want to install is Visual Studio Code, which looks something like this. It should auto detect it, and we're going to go ahead and download this for Windows. I'm going to walk through all the installation process. Go ahead and create a desktop item. We'll add this just in case we want to open with code, and we'll go ahead and install. And then we'll go ahead and finish. Once you've installed Visual Studio Code, you'll see something that looks a little like this. It'll go ahead and give you this Get Started with VS Code section where you can choose some themes and you can choose kind of the way it looks. Feel free to customize it the way that you want. If you want to learn a little bit more about Visual Studio Code, I highly recommend you walk through this section to learn more about the shortcuts and making your development experience more efficient. When you're done, you can just go ahead and close the tabs at the top, and it'll look a little something like this. Once we have Visual Studio Code installed, the next thing that we're going to want to install is Node.js. And of course, we have a link to installing this in the GitHub repository associated with this course. What we're going to do is we're going to go ahead and come to nodejs.org to download this for Windows. Node.js is a JavaScript runtime environment. It's not exactly JavaScript, and the distinction can be a little bit confusing, but just know it's going to help us run our JavaScript code for our development environment. Let's go ahead and download the LTS, or the long-term support edition of Node.js. We'll go ahead and we'll run through the setup wizard. And we'll go ahead and make sure that this is clicked just in case we ever want to use some different tools with our setup. And then we'll go ahead and click install. You'll get a pop-up asking if you really want to install this on your device, and we'll go ahead and hit yes. And then we'll hit finish. You might get a pop-up that looks like this. Go ahead and click any button to go ahead and install the tools. Go ahead and press any key again, and you'll likely get a Windows PowerShell screen pop up asking you to go ahead and install a whole bunch of different projects and files. If you chose not to install this, that's totally okay. But in the future, this will be really helpful since we are going to use a lot of tools that this package installs anyways. This might take some time to install, so go ahead and be patient. And if it gets stuck, it might just be waiting for you to go ahead and hit enter. So go ahead and hit enter for any prompts. But yes, please be patient with this. It can be a little bit slow to go ahead and install everything. Once you have all that installed, you can come back to your Visual Studio Code, and we're going to go ahead and open up a terminal. To do that, we hit terminal and we hit new terminal. A terminal is going to be our command line prompt where we're going to basically run all of our scripts to work with our code. And if you run node -- version, you should see something that looks like this to know that you've installed Node.js correctly. Now this command line is known as Windows PowerShell. If you want to work with Windows PowerShell, you absolutely can. In fact, if you want to be a total hardo and write all your code through Windows PowerShell, you can absolutely do that as well. However, we're actually not going to be working with PowerShell. We're going to be using a tool that makes our Windows environments more like Linux. The reason that we're doing this is Linux is the standard for most development environments, and having everybody work on a very similar setup will make the rest of this course a lot easier for everyone to interact with each other, no matter what coding environment they're working on. WSL stands for Windows Subsystem for Linux, and it allows Linux programs to run natively on our Windows environments. To get this set up, we're going to go ahead and go to the WSL install, and we'll have a link for this as well in our GitHub repository. So what we're going to do, you must be running a Windows 10 version 2004 or higher, or Windows 11. If you're using an older version of Windows, you can absolutely continue with PowerShell, but you might run into some issues where all the commands don't work exactly the same. So I highly recommend working on a newer version of Windows. To install this, back in your Visual Studio Code PowerShell, or just the PowerShell app by running WSL --install. Now, if you get this error, the requested operation requires elevation, it means that we have to run our Visual Studio Code or our PowerShell application as administrator. If we close out our Visual Studio Code and right-click it and say run as administrator, we get a little pop-up saying, do you want to allow this app to make changes to your device? We'll go ahead and click yes, and then we'll reopen the terminal. And then we can run WSL -- install. And we'll go ahead and install WSL. This may take a little bit, so please be patient. Once it's completed, you'll see something that looks like this. We're going to be working with Ubuntu, and we have a list of different commands to change your Linux distribution if you choose to do so. And you'll see the requested operation is successful. Changes will not be effective until the system is rebooted. So you'll want to go ahead and restart your computer. There's also a troubleshooting guide in the GitHub repository if you run into issues. After you restart your computer, you'll be prompted for a name for your new system and a password. This can be different from your Windows name and password. And then just follow through with all the prompts. And then, once you're done, you'll be dropped into a Ubuntu shell and you can run Linux commands. And now you'll have a Ubuntu instance on your machine, and you'll be able to run Linux commands in your terminal. Now that we have WSL set up correctly, we're going to go ahead back over to Visual Studio Code. Once we have WSL, we'll want to go ahead and install an extension. So in our Visual Studio Code, we'll go to Extensions, and we'll look up Remote Development. You can install the whole thing or just Remote WSL. We're going to install the whole thing. You can follow along the Get Started with Remote WSL if you like, or you can just follow along with me right now. Right now, if I go to the terminal and hit New Terminal, I'm still going to get PowerShell. We actually want this to be our Linux shell. So there are a couple ways to open Visual Studio Code up in our Linux environment. One way is you can hit Control-Shift-P and type WSL, and then click Remote WSL, New WSL window. And you'll get a new window that looks like this. You can also click the bottom left and choose New WSL window. Now, if we go to our terminal and hit New Terminal, we'll be dropped into a bash shell and we can run Linux commands in here. Awesome. Another way we can open up Visual Studio Code with WSL on is we can go into our Ubuntu application. We can make a folder by typing mkdir folder. We'll cd or change directory into folder and type code, period. We'll go ahead and trust the authors in here. And this will open up Visual Studio Code already connected to the folder that we're in. And we can create files in this folder like hi.txt, and those will get created inside the folder in our WSL. Now that we're inside our WSL environment, you'll notice that node -- version doesn't work anymore. That's because we installed it on our regular Windows machine and not on our WSL or our Linux environment. The reason we installed it on our Windows environment first is so that just in case you wanted to go ahead and use PowerShell or use your Windows environment to run everything, you still can. But just remember, if you use the Windows environment and PowerShell, all the commands that we use might not work for you. So we're going to go ahead and install Node.js on our Linux environment now. All the commands that we're going to write are going to be in the GitHub repo associated with this course. we're going to do a curl command to the NVM repository, which stands for Node Version Manager. And we're going to pipe the install script into bash. And this will go ahead and install NVM. After running that, we go ahead and trash the terminal and then reopen it. And then we can type nvm -- version to see if it actually installed correctly. Once we've installed NVM, we can go ahead and install Node.js using NVM. Just type nvm install, and we'll do 16.14.2. This is that same long-term support version we installed on our Windows machine. Once we have it installed, we can type in node -- version, and now we have Node.js installed. Now, I know there was a lot here, but if you made it this far, this is fantastic. You've done a great job to push through to this point and get everything set up so you can code in the best environment there is. So if you've made it this far, huge congratulations. Now, the next thing that we're going to install is Git. And now, we're not going to use Git for this lesson. However, we will definitely be using it in the future. To see if Git's installed, type git -- version. Sometimes Linux will automatically come with Git installed, and you'll see something output like this. If you don't have Git, we can just look up the Git install, which again, link to this is in the description, and you'll actually run the installing on Linux. Now, if you want to use PowerShell and you want to do everything with Windows, you can absolutely follow the installing on Windows instructions here instead. When you're working in WSL, you'll want to use the Linux commands instead of the Windows commands, even though you're on a Windows, because WSL makes it so that you're basically running in a Linux environment. And now, if you've made it this far, you should be able to follow along with the Mac and Linux instructions as if you're running on a Mac and a Linux, even though you're running on a Windows. Just be sure that whenever you're in your VS Code, you take a look at the bottom left and make sure you're on WSL Ubuntu. Like I said before, if you want to run in PowerShell or in a Windows environment, you're more than free to do so. But like I said, if you've made it this far, huge congratulations. Awesome work. And then finally, our last setup is going to be using a tool called Gitpod. Starting from lesson 5, the lesson that we're on right now, Ethers.js Simple Storage, all of our code repos are going to come with a button. In the repo, if you scroll down, they'll come with this Open in Gitpod button. Now, Gitpod is a cloud development environment where you can actually run your code on a remote server. It's kind of similar to Remix IDE, but it allows you to run Visual Studio Code in the browser or connected to another server. This is good because then you don't have to do any installation on anything, since all the tools that you want to use are just going to be running on this remote server. This has its downsides though, obviously, since you'll only be able to code if Gitpod is up and working for you. Additionally, when it comes to private keys, you absolutely do not want to run any code with a private key that has real money in it on Gitpod. Why? Well, once again, since you're running your scripts on a remote server, those servers have access to your private keys. But since you've pinky promised that for this course, you're not going to be using a MetaMask or a private key with actual money in it, it should be fine. The other downside is that these often cost money to use, and Gitpod isn't free, but it's an option if you absolutely cannot get any of the installation working. So if you go ahead and you hit this Open in Gitpod button, you'll get a welcome to Gitpod showing up. We're going to go ahead and continue with GitHub since you've signed up for GitHub here. You'll want to go ahead and authorize Gitpod. And it'll go ahead and start creating this workspace for you. And you'll notice it looks exactly like Visual Studio Code. Since I opened the repo up in Gitpod, it came with all the code. And you can even open this workspace up in VS Code Desktop. So this might be a little bit confusing, but basically you can run off of Gitpod using your local Visual Studio Code. And if you see Gitpod here, that's how you know that you're running off of Gitpod. If you see this pop up, do you want to open this workspace in VS Code Desktop? You can hit open and it'll ask you if you want to open up Visual Studio Code, which I'm going to go ahead and hit yes. And you'll get something that looks like this on your Visual Studio Code. It'll tell you that it wants to install the Gitpod extension and then open that Gitpod URL. So you can go ahead and install it, reload window and open. and it's going to go ahead and start connecting to the Gitpod workspace. And this is going to be the same as running Gitpod in the browser here. Or you can also do it manually by hitting the Gitpod in the bottom left and then type in open in VS Code. And then you should be able to run it in your Visual Studio Code. For now, I'm going to recommend that if you're using Gitpod, just stay in the browser, just so that you know, okay, I am running this on a remote server, and just as a reminder for you that you're not actually locally developing. And hopefully this will be a trigger to not actually put any special private keys or anything like that. But you can make workspaces, you can make new folders, and you should be able to run all the commands on here as if you were running locally with Visual Studio Code. To open up the terminal, you can hit this little bar in the top left, go to terminal, new terminal, or use Control-, the exact same as Mac OS and Linux keyboard shortcuts. To create a new folder, we can change directory, cd ... mkdir, new folder. mkdir makes make directory called new folder. And then we're going to change our directory into new folder and hit enter. And now we're in that new folder. For each section, you can either open up the entire source code right into Gitpod, or you can create a new folder for each section yourself and start from blank. And then you would just type code, period, and you'd be in a brand new folder. All right, this is fantastic. At this point, you should be set up with Visual Studio Code, Node.js, and Git. And I'm going to be working out of a folder called Hardhat Free Code Camp. At this point, you should have node --version git --version. And if you're using Windows, this should say WSL or Ubuntu or something like that. And if you have all that, that means we're ready to go. Now, a quick note, something that you'll see me do a lot, and you can do this as well. Oftentimes, when my terminal gets really, really big, or there's a ton of commands in here, it gets a little bit overwhelming for me. So one thing that you can do is you can type clear and hit enter to clear it. Or what you can do is you can hit Command K if you're on a Mac, or Control K if you're on a Linux or a Windows. And it's one of my favorite keyboard shortcuts that I use all the time. Additionally, the trash can and the X here are very different. If I go do a couple of enters here and we're down here, if I hit the trash can and then pull my terminal back up by doing the toggle or by doing terminal, new terminal, you'll see all those lines are still here. But if I hit the trash can and then pull the terminal back up, you'll see it actually refreshes. Mine is a special command that prints stuff out. Trashing your terminal is basically deleting whatever's running in it, and the X is just hiding it. And it's hitting Control _ or toggling our terminal, or whatever command it is on your environment, that's equivalent to hitting the hide, not the trash. So if we want to remove and start a terminal over, we hit the trash can, and then we pull it back up. All right, so now we're going to start working with ethers, and we're going to start learning to code our transactions and our contract deployments and everything programmatically at a relatively low level. And we're going to learn how to deploy and interact with our contracts using the Ethers.js package. Now, to get started, I'm going to recommend you create a folder where you're going to put all of your projects in it. I'm going to create a new directory called HH-FCC, which stands for Hardhat Free Code Camp. And once we run that command, we can cd into HH-FCC, and this is where we'll create all of our projects for this course moving forward, so that we have them all in one place. Now, to get started, whenever you create a new project, you always want to create a new folder. So to create a new folder, we're going to do mkdir, and we're going to call this Ethers Simple Storage, like that. And now, if you type ls, you'll see that there is one folder named Ethers Simple Storage. ls is how you list all the contents of your folder. You might have a lot of other folders in here. I only have the one since I created this new folder for this. Now what you can do, you can type code, ethers simple, and then if you hit tab, it should autocomplete for you. And if you hit enter, Visual Studio Code should open up a new Visual Studio Code for you that is inside of Ethers Simple Storage. If you open up your terminal now, your home directory for this workspace is going to be Ethers Simple Storage, as this is what pops up. If that doesn't work for you, what you can also do is you can hit File, open folder, and then open the folder that you just created or that you want to open. This again will open up VS Code. And if we open up our terminal, we see we're inside of Aether's simple storage. This is so powerful because as we create files, we'll be able to see those files in our Explorer here. This button here stands for the Explorer. If we click it, we can see the different files in here. And I'm going to go ahead and actually delete this file.txt because we're not actually going to use that. Now, it's this part of the course where we're actually going to start jumping into some JavaScript. Since this course isn't a JavaScript course, if you're unfamiliar with JavaScript, it might be a little bit tricky. If you want to come into this with a better understanding of JavaScript and Node.js, there is a Free Code Camp YouTube video teaching Node.js for beginners, and a link to this will be in the GitHub repo associated with this course. There's also a JavaScript Free Code Camp video that I'm also going to put in the description for this course. Keep in mind that JavaScript and Node.js are slightly different, and we are going to go over some of the differences as we code along here. But for the most part, learning one means you've learned the majority of the other. So if you want to pause and go through these videos before continuing here, please feel free to do so. You don't have to. You can absolutely continue on with the course as is. And if you get confused or stuck on some JavaScript piece, feel free to pause, Google it, and come back. But just to reiterate, you can check out the JavaScript programming full course and also the Node.js full course, as those are both going to help you. Like I was saying before, Node.js is a JavaScript runtime. So it's not exactly JavaScript, but we're going to write our code in JavaScript. And if that's confusing, just don't worry about it right now. And as we go through this course, I'll show you where the differences are. But basically, you can think of Node.js and JavaScript kind of being the same thing. The big thing about Node.js is it allows us to write JavaScript code in the back end, as opposed to running JavaScript on the front end. JavaScript is made to be a browser run language, like running inside of, Chrome, Brave, Firefox, etc. Node.js allows it to become a scripting language, a backend language, which is why the syntax between the front end JavaScript and the back end JavaScript or the Node.js JavaScript are going to be a little bit different. Additionally, as we go along in this code, if you're familiar with TypeScript, all of our code is going to come with a TypeScript edition. TypeScript is what's known as a statically typed version of JavaScript. And it'll be this one. It'll be TypeScript, not TypeScript edition. I'll go ahead and fix that and remove this one to make it clear. TypeScript is a type-safe version of JavaScript, which, if that's confusing, don't worry too much about that. But we are going to do all of our programming in JavaScript. And then if the code is different enough, I'll show you how to do it in TypeScript as well. However, for most of them, we're not going to show you the TypeScript editions because it's going to be really similar, but you can always refer back to the GitHub repository to see all the code for the TypeScript. Now, if you're new to this space, I actually do recommend you go ahead and start with JavaScript and learn how to do TypeScript later on. TypeScript actually catches bugs early on, making it a lot easier to code your projects in the long run. However, it does take a lot of extra typing, and it can be a little bit frustrating learning how types work for beginners. JavaScript is a little bit more loose as a language and lets us to kind of do whatever we want, but it can cause for headache later on. So if you do run into some issues and you do run into some bugs, it might be a good idea to try TypeScript on for size and see how that fares. Well, let's go ahead and begin working on our local development environment and getting set up to do everything in Ethers.js and in JavaScript. Whoops, and I actually went and renamed this folder to Ethers Simple Storage -FCC. The reason I added this -FCC is all the GitHub repositories associated with this course, all the GitHub repos have this -FCC to know that it is part of this hard hat JavaScript course. Awesome, let's jump in and let's start working with Solidity and our smart contracts locally in Visual Studio Code. As you can probably tell by the name of this folder, and of course, if you looked at the code, this project is going to be our simple storage project, but developed locally using Ethers. So the first thing that we want to do is we want to get in that smart contract code. So what we can do is make sure we have the Explorer selected. We can go ahead and right click and select new file and do simple storage.sol. Just close this for now. Is we can copy paste our simple storage code from our last section into VS Code. If you closed Remix or you forgot where it is, you can just go to the Ethers Simple Storage FCC repo, hit simplestorage.sol, And we can just copy all the code in here and then come back over, select simple storage.sol and paste it in. Now, an important note about Visual Studio Code is that when you see this little white dot up here, it means that this file isn't saved. To save, you can hit File, Save, and it'll go away like that. Or what you can do is you can hit Command S or Control S, depending on if you're on a Windows, a Mac, or a Linux. Now you'll see here that this code is a little bit hard to read, this simple storage.sol. It doesn't have the syntax highlighting that we saw in Remix. So we want to go ahead and add a Visual Studio Code extension to give this syntax highlighting. So what we can do is come over to this bar over here. Looks like this. And if you don't see it on the left-hand bar, you should click these three dots and it should be in here. But we'll go ahead and click extensions. And what we're going to do is we're going to look up Solidity plus Hardhat. And we're going to install this Solidity plus Hardhat extension for VS Code. Now that we have this installed, if we go back over to our simple storage.sol, you'll see that all the highlighting is back in. And now it's much easier to read. All right, so this is good. We have our code in here. We have our syntax highlighting. Now let's add an auto formatter or a default formatter. Right now our code is pretty good with the way that it's formatted, but what if we accidentally do some stuff like this, or maybe even like this. We add a ton of new lines, etc. Our code can start to look pretty gross. And even though the code itself is fine and it'll run the exact same way with all this extra white space, it doesn't look very good, right? And due to that, it can be a little bit hard to read. What we want to do then, we want to open up our settings and adjust our VS Code so that it auto formats whenever we save. So whenever we save, so that whenever it goes from the little white dot here to no white dot, this whole thing gets automatically formatted to something that looks really nice. Okay. So what we can do is we can open up our command palette. To open up our command palette, you can hit View, Command Palette, and it'll get a little pop-up that looks like this. Another way to open up your command palette is you can hit Command Shift P or Control Shift P, depending on if you're on a Mac or a Linux or Windows. And what we want to do is we want to type in settings, and we're going to open settings JSON. We don't want to open the default settings JSON. We don't want to touch these, but we want to open our JSON settings. You'll also notice there are user settings and workspace settings. These are pieces that we can adjust as well, but we're going to just go right into the JSON settings. So I already have some stuff in here, but yours might be blank, or you might have some stuff in here as well. So what we're going to do is, if you have stuff in here already, we're going to add a comma. Then we're going to do quotes, Solidity, close the brackets. We're gonna do a little colon and something like this. This means that we're gonna apply some settings to our Visual Studio Code whenever we're working with Solidity. One of the things that we're gonna add in here is gonna be an editor.default formatter. And you might even get a pop-up that tells you some different things that we can use for a default formatter. Our default formatter is gonna be Nomic Foundation.hardhat-solidity. This will mean that anytime we go to format our code, it'll use the Hardhat Solidity plugin as its default formatter. The Hardhat Solidity plugin comes with some formatting and a lot of other really useful tools for us writing our code. So now that we have this part in, the next thing we're going to do is add format on save if we haven't already. We could add it in here in our JSON, but I'm going to add it not in the JSON file. I'm going to add it in the overall file. So if we open that command palette back up, we type in settings, open user settings. This is another really good place where we can look and add settings with a UI. So these two do essentially the same thing. It's just that this one has styles and a little bit more context versus settings.json just says, okay, give me the raw code for it. This tells us a little bit more. So you can use either one. But we're going to look for format on save. And you're going to want this checked if you haven't already. This means that every time we save, VS Code is going to try to format our code for us. So now that we have this checked, we have settings.json added in. And remember, we want to save this. Remember, if you see this white dot, that means it's not saved. So you're going to want to save it. and we close it out, and we close this out too, if we come back in here and we add a bunch of random new spaces or whatever you want to make it look a little bit ugly, and then we save it, it should automatically reformat to look much nicer, right? So if we do something like this, we hit save, it reformats it to look much nicer. This will make it more readable for you and more readable for anybody else who looks at your code, and it's just really nice. And this line of code for your settings.json is located in the full blockchain solidity course.js, so you could also just copy paste it. We are going to end up overriding that default formatter with another formatter called Prettier pretty soon. But it's great to have a default formatter so that if you don't feel like adding the Prettier code sometime in the future, you can just rely on your default formatter. Awesome. While we're doing formatting, let's also add a default formatter for our JavaScript code. And just to test it out, let's go ahead and create our new file. We'll call it deploy.js. And in here, we can do something like function hi, console.log, hi. And then just add, and then just make it look kind of gross. Maybe something like this. If you hit save and it does some auto formatting, that's great. You can actually turn that off by going back to your command palette and saying save without formatting, and that way it'll be saved and not formatted. The way we can add some auto formatting here is we're going to install another extension. This one is going to be called Prettier. So we can just look up Prettier in the extensions here, and you'll want to install this Prettier code formatter. So we're going to go ahead and install this, and great, now it's installed. Prettier is a code formatter that works for many languages like Python, JavaScript, and even Solidity. And pretty soon we're going to use Prettier for both JavaScript and Solidity. But for now, we're just going to use Prettier for JavaScript. We can enable this by opening back up our command palette. We'll go to Preferences, Open Settings. And the same way we added a Solidity section, we're going to add a JavaScript section. So we're going to add a comma here, some quotes, brackets. We're going to type in JavaScript, close that, colon brackets. And we're going to do the same thing. Editor.default formatter. And then we're going to do, and then in here, we're going to do esbenp.prettier-vs code. And this will make Prettier the default editor for JavaScript. Now, like I said, pretty soon, we're going to have Prettier override both of these for Solidity and JavaScript. And we're going to give Prettier some parameters so that no matter who uses your code, they will always have the exact same formatting. But now that we have Prettier in here as the default editor, if we come back to deploy.js and we hit save, it should format to look a little something like this now. And we go ahead and we do something like this. If we go ahead and do something like this, it'll reformat to look like that. And then additionally, if you want to go back to your command palette, open user settings, not in JSON mode, and we go to default formatter, you can actually even select the default formatter for all languages. If you want to use Prettier for all formatters, feel free to go ahead. But all right, great. Got our JavaScript formatter in as well. Let's start writing some JavaScript code. Awesome. So now that we have our code in here, it's time for us to learn how to actually deploy our contract using JavaScript. This is going to teach us a lot about transactions and what's going on under the hood, and even what's going on under the hood in Remix. In Remix, we usually just hit a compile button and then hit a deploy button, and that's really it. In JavaScript, we're actually going to create our own functions that are going to help us do both of those. And as I mentioned, this is the part of the course where we're going to start working with JavaScript and optionally TypeScript if you like. Like I said, all of these sections come with a TypeScript edition as well. So let's set up our deploy.js script to actually deploy our simple storage.sol. So how can we get started here? Well, let's first learn how to run a script using JavaScript and Node.js. So if you want to do a print line or just print something out to your terminal, what you can do is something called a console.log. And if I do console.log hi, I hit save, and I open up my terminal, I can now run node deploy.js, and it'll print out hi. Node is how we say, hey, we want to run this JavaScript code using Node.js. Other languages you might be familiar with, sometimes we'll do Python, deploy.py, or Java C, deploy.java, etc. But with JavaScript, since the front end and back end JavaScript are different, we run code on the back end with Node. And with JavaScript, you can do a lot of things that you'd see in something like Solidity with a little bit looser of a structure. If I wanted to create some variable, I could say let variable equals 5. This is kind of similar into Solidity, like uint256 variable equals 5. But in JavaScript, we use let or var or const. And then I can print this out. I can do console.log variable. And I hit save. JavaScript is optional on whether or not you actually want to have semicolons here. I think prettier defaults to putting semicolons, and we'll get rid of those in the near future. In your terminal, once you start typing the name of a file, if you hit tab, it could auto-complete the rest of the file name for you. Node, deploy, hit tab, it'll auto-complete. And if we hit enter now, we get hi, and then we get 5, since it prints out hi, and then it prints out 5. JavaScript automatically starts with whatever code you have at the top of the file. So it does console.log first, then variable, and then this one as well. However, a good practice is to actually wrap everything you want to do in a main function and then run that main function. So what we could do is up at the top here, we'd say function main, add some parentheses and some brackets, a closing bracket at the bottom, and hit save for it to auto format. Right now, if we run this, nothing will happen because we've wrapped all of our code in a main function. So if I run it now, node deploy.js, nothing happens because I need something to call the main function. So if I then take this main function down here and I call main, our JavaScript code is actually going to say, the first line of this script is actually this main function here. So now if I do node deploy.js, it'll run hi and 5, which is what we want. Now, this is going to be the setup for most of our scripts moving forward, including the scripts that we write when we get to Hardhat. However, there is going to be one major difference. Instead of regular functions, we're actually going to use something called async functions, and we're going to do something called asynchronous programming to do this. Now, if what I say next is really confusing for you, don't let it slow you down. Feel free to go ahead and watch that JavaScript course to learn more about this, but I'll also let you know, hey, this is an async function. Here's what we need to be aware of when working with it, okay? But I do want to give you a quick background on asynchronous programming. So far, the programming that we've done has been synchronous. And Solidity is an example of a programming language that's synchronous. Synchronous means it just goes one line after another. If our code looks like this is synchronous, right? Our main function is the first thing that actually gets called. Then we do console.log, let variable equals 5, and then console.log again. This is synchronous programming in JavaScript. All of our Solidity is synchronously programmed. There will be some exceptions to this when working with oracles, but for now, everything is synchronous.
JavaScript can be asynchronous,
meaning that we can actually have code running at the same time. Good example I like to use to understand the difference is with cooking. In synchronous programming, for cooking, you might put popcorn in microwave, wait for popcorn to finish, and then maybe you'll pour drinks for everyone. And now this is synchronous programming. Now it might be a little bit weird for you just to put the popcorn in the microwave and then just stare at it, waiting for it to finish, and then pour the drinks. You typically can pour the drinks while your popcorn is in the microwave. And this is where asynchronous programming comes in. If setting up for this movie night were asynchronous, what you would do is you'd put popcorn in the microwave, and while the popcorn is in the microwave, or drinks for everyone, and then you'd wait for popcorn to finish, since there's nothing left for you to do. But it doesn't make sense for you to wait for the popcorn to finish to pour your drinks. You can just go ahead and pour the drinks right away and then wait for the popcorn to finish. So asynchronous programming is a way for us to do stuff without waiting around for things to finish. And this is really advantageous. And JavaScript by default allows us to do this asynchronous programming. However, sometimes we do want to wait for our popcorn to finish. For example, if instead of just pouring drinks, maybe the next thing instead of pouring drinks was place salt on popcorn. Of course, if we want to place salt on our popcorn, we do have to wait for the popcorn to get out of the microwave. So So even though placing popcorn in the microwave has this wait time, we need to be able to tell our code, I want you to actually wait for it, or no, you're good. You can go on and do another task. So that's kind of the difference here. And I'll leave some links in the GitHub repo associated with this course to understand this a little bit better. Functions that come with this waiting period return something called a promise. If put popcorn in the microwave was a function in JavaScript, it would be a promise-based function. A promise can be either pending, fulfilled, or rejected. And this is how we know if our popcorn is done. If our popcorn was a method, putting popcorn in the microwave were a function in JavaScript, when we're waiting for the popcorn to finish, it's in a pending state. When the popcorn is finished, it would be fulfilled. And if we aborted halfway through and we stopped waiting, it would be rejected. So putting the popcorn in the microwave returns a promise. With this promise, we have to tell our code, hey, we want you to wait for the popcorn to finish, or you can go ahead and you can just keep doing stuff. So let's put this all together with some JavaScript syntax here. Let's say, again, we're going to be setting up this movie night, and we need to cook popcorn, pour drinks for everybody, and then we need to start a movie. So let's write some pseudocode to pretend what this code would look like if this was actually a function. So we'd create some function called setup movie night. And in here, we would say, okay, what's the first thing we need to do? Okay, we need to cook popcorn. So let's say we have some cook popcorn function. So we'll say, okay, cook popcorn. Then the next thing we're gonna have to do is we're gonna have to pour drinks. Pour drinks. So we'll call some pour drinks function. Now, here's the thing. We only want to start the movie once our popcorn has been cooked and once our drinks have been poured. So if either one of these returned a promise, like cook popcorn, for example, we would need to tell our code here to actually wait for the popcorn to finish. Because cook popcorn is going to be a function where we could say let status equals cook popcorn. And while the popcorn is being cooked, the status is going to be pending. Once the popcorn gets cooked, it'll be fulfilled. If the popcorn breaks, the microwave explodes, the status would be rejected. But we don't want the status to be in a pending situation before we move on. We only want to start our movie once these two functions have completed. And let's say both of these return these promises things. So we need to tell our code, hey, you have to wait for cook popcorn and for pour drinks to finish. So what we can do now, without getting too deep into the weeds on how all of this works, one of the easiest things that we can do, and you'll see us use this syntax quite often, is we'll turn this function into an async function. When our functions are async, we get access to a keyword called await. The await keyword tells any promise-based function to wait for that promise to be fulfilled or rejected. So we say, okay, we want to await for our popcorn to cook, and then we want to await to pour our drinks, and then we can just go ahead and start the movie. And we only start the movie here once these two have been completed. And this is why throughout all of our code, you'll see this await keyword used a lot, but it can only be used in async functions. So basically, whenever you see this await keyword, just know, okay, the function that's being called is promise-based, and we don't want to move on to the next step until that function has completed. So that's a little bit more about promises and asynchronous programming. Hopefully that's clear. If not, like I said, there's some links in the description to learn more about asynchronous programming. The reason I wanted to go through this is because most of the functions that we're going to be working with are going to be asynchronous. For example, when we deploy a contract, what do we have to do? Well, we have to wait for it to be deployed. If we don't use synchronous programming and we just leave our function main like this, what would happen is we would write some code like contract.deploy, and we wouldn't wait for it to finish. Obviously, if we don't wait for it to finish and we try to run some code on a contract that hasn't finished deploying yet, it's not going to work. So we want to do this. We want to have our main function be an async function so that we can wait for our contracts to deploy. We can wait for things to happen. We can wait for our popcorn to finish. We can have the flexibility to tell our code to either wait for our popcorn to finish or continue on. So now that we have our main function as an async function, we're going to add some code to our main function down here. And the code that's added here is some syntax for working with asynchronous functions. And if this part is confusing, I'm just going to say for now, absolutely don't worry about this. If you want to try to understand it later, that's fine. But for those who are following along, we're just going to add a then catch error. You can follow along typing this yourself, or you can just copy paste it into your code. Basically, what this allows us to do is we have our main function that's an asynchronous function. So when we call the main function, this is some other syntax for waiting for it to basically finish and then printing any errors it gets. And that's why we do this. But again, if this big lump of code, if you're like, what is going on with this big lump of code? Honestly, for now, just copy paste it. So great. We have our asynchronous function main, we have some code, and then we have this lump of code, which basically just calls our main asynchronous function. Okay, great. I'm going to delete all this for now, but you can still find that comment in the GitHub repo associated with this course. Awesome. Okay, so now that we have our real basic setup, let's go ahead and start coding. And if this setup part is confusing and the async await stuff is confusing, don't worry too much about it. It'll make more sense as we progress. All of our code basically is going to be inside this async function main, which is going to be our main script for deploying our simplestorage.sol. So our deploy script is going to replicate exactly what goes on in Remix. In Remix, what was the first thing that we always did? Well, the first thing that we would do is actually compile all of our code. So we're going to want to compile our code in our JavaScript project as well. In order for us to compile our simple storage contract, we're going to use a tool called Sulk.js. Now, JavaScript actually has a way to install projects directly into our setups and into our folders. If we scroll down, this Sulk.js is exactly what we're looking for because it has a way to compile a contract that imports other contracts via relative paths. You can see a section in this README, and most documentation will have something like this if it's JavaScript compatible for Node.js usage. It says to use the latest stable version of the Solidity compiler via Node.js, you can install it via npm install Sulk. npm is what's known as a package manager. And we actually installed npm just by installing Node.js, right? If we do node -- version, you should also be able to do npm -- version. Another tool that it comes with is something called Corpac. And you can type Corpac -- version. Now we can install with npm using npm install Sulk. However, I like the Yarn package manager a little bit better. So we're actually going to install the Yarn package manager instead to do all of our package management. If you go to the installation page, the newer way to install Yarn is just by running Corpac enable, and the older way is to install with npm. If you go ahead and run Corpac enable, after that finishes, you should be able to run Yarn -- version. Alternatively, you can just run npm i -g Corpac, and then you can run Corpac enable. The last option you have is you can run npm i -g yarn. This will install Yarn globally for your system, but this is considered the outdated way to install Yarn, and ideally you run Corpac enable. But in any case, after you run those, if you run Yarn -- version, you should get something that looks like this. Now that we have Yarn, we can actually use Yarn to install all of our projects instead of npm. Back in Sulk.js, where it says npm install Sulk, we can do the Yarn equivalence of npm install Sulk, which is going to be Yarn add Sulk. This will actually go ahead and install Sulk to our project. If we open up our folders, you'll actually see that this added a couple of different folders. It first added a package.json. Package.json is a file that tells us a lot about our project and the dependencies that it works with. For example, we've installed the Sulk package of 0.8.13. Our yarn.lock tells us the exact version of all the different packages of our project. For example, the reason this is so important too is Sulk has a ton of dependencies as well. So yarn.lock tells us exactly what version of Sulk and all the different dependencies of Sulk and any other project that we add. This is an auto-generated file. Don't edit the file directly. The final bit is we get this node modules folder. This node modules folder is going to be where all the installed code that we just downloaded is. For example, if we look in node modules, we can see there's a Sulk folder, and inside this Sulk folder is all the code associated with this Sulk package that we just installed. And since we're working with 0.8.7 of Solidity, we actually want to install that specific version. So we're going to do yarn add Sulk at 0.8.7 -fixed. And you'll see in our package.json, you can now see 0.8.7 fixed in our dependencies section for Sulk. Normally, you can just add your Sulk version like yarn add 0.8.7, but there was an issue with 0.8.7, so we had to do 0.8.7 fixed. You can find the different releases and the different versions if you go to Sulk.js releases and then to tags. All right, great. Now that we have Sulk, we have the ability to actually compile our contracts. We could either compile them in our code and have it automatically run whenever we hit deploy, or we could compile them separately. If you want to go back after this section, there's an example in the Sulk.js repository that shows you how to actually compile Sulk right in your code. We are actually going to compile them separately using a Sulk.js command. The yarn command is both used to install dependencies and it can be used to run scripts. If you go to Sulk.js and you scroll down, it says in order to use the command line, you actually need to install it globally. If you want to install this globally using yarn global add Sulk at 0.8.7 fixed, you can absolutely go ahead. However, since we're inside of this folder here, which has the yarn.lock, the package.json, and the node modules, Yarn will be smart enough to know, you're looking for the Sulk in this folder. So we can actually go ahead and compile our contract using Yarn and Sulk.js. If you want to see all the different commands Sulk.js allows, we can just run yarn Sulk.js --help. And you'll see it'll spit out a list of all the different options that Sulk.js has. You can also run yarn Sulk.js --version to just make sure that we're on the correct version, which is indeed 0.8.7. Now, to actually compile our simple storage.sol, let's run the compilation command. We'll run yarn Sulk.js --bin, since we want the binary, --abi, since we also want the ABI, --include path node modules, since we want to include any contracts or files in our node modules. We aren't using any for this project, but in the future, you will need to include this --include path node modules. We'll do --base path of period. This period means that the base path is going to be this folder, -o period, which means we're going to output the compiled binary and ABI to this folder. And then finally, simple storage.sol, since this is the contract that we want to compile. I auto-completed it from simple storage to simple storage.sol by typing simple and then hitting tab. But let's go ahead and hit enter. You'll see it's running this command to compile this contract. And you'll see two files get output, one called simple storage sol _ simple storage.abi and simple storage sol _ simple storage.bin. The ABI is obviously the ABI of this contract, which we'll need in the future. And then the bin is going to be the binary, or the really low level of this code. Back in Remix, if you compile simple storage.sol, you can actually look at compilation details, like the ABI, which we just got, or the bytecode, which if you look at this object, 60806, that's the same as the binary here, 60806. All right, great. So now we've compiled our contracts here. Now, obviously, if you hit up on your keyboard, you can actually cycle through your most recent terminal commands. And if you hit up enough, we can see this command that we just ran. Typing this out or hitting up a whole bunch every single time is going to be really annoying to do anytime we want to recompile. So what we can do is we can add a scripts section in our package.json to shorten some yarn scripts for us. So what we'll do is back on our package.json, we'll add a comma and we'll add a section called scripts. Add the colon and the brackets. And in here, we'll say anytime we say compile, we will run this long command. So we'll add compile, we'll put some quotes, and we'll paste that in there. So now, instead of typing that whole thing out, as long as we're in the same folder that our package.json is in, we can run yarn compile, and this will run that whole script for us without us having to type the whole thing out. Scripts are a really useful way to make it easier for us to run long commands. All right, great. Now we have our code compiled. This is going to be equivalent to us hitting this compile button for us to actually go ahead and deploy. So now we have our simple storage.sol compiled. let's learn how we can actually deploy this thing. Remember, in Remix, we actually deployed it to one of two different places. We deployed it to either a JavaScript VM or with our injected Web3, with our MetaMask. Let's learn first how to do the JavaScript VM, and then we'll learn how to use the injected Web3, or a MetaMask, or some connection to an actual testnet. So in order to deploy this to a JavaScript virtual environment, or kind of a fake blockchain, we're going to need to get a fake blockchain. Now, in the future, we're going to be using the Hardhat runtime environment as our JavaScript virtual machine, or AKA our fake blockchain. But for this section, I want us to use a tool called Ganache. There's a link to this in the GitHub repository. Ganache is similar to a virtual machine in Remix. It's a fake blockchain that we can run locally to actually test, deploy, and run code. It's also a nice way to see things that are going on in a blockchain. Let's go ahead and spin up the Ganache application after you install it. The Ganache application will look a little something like this. And to spin up a fake blockchain really quickly, you can just go ahead and click Quick Start. This will spin up a fake blockchain that's running locally on your computer right here, which is fantastic. It comes with a whole bunch of fake accounts, exactly like how Remix comes with a ton of fake accounts with 100 Ether each. Ganache comes with a bunch of fake accounts with 100 Ether each. They also come with the private keys that we can use in our applications to actually take control of these fake accounts. Remember, don't use these private keys on a public blockchain. They're for development purposes only, because a lot of people know these private keys. In our code, one of the first things that we're going to need to do is actually connect to our blockchain. Remix does this a little bit behind the scenes. If we're choosing JavaScript virtual machine, Remix chooses its own fake blockchain that it runs. If we choose injected Web3, as we know, MetaMask pops up and it connects to our MetaMask. This connection that Remix does is actually doing something really interesting. It's not just connecting to our MetaMask by some magical powers. It's actually connecting to our MetaMask, which has a connection to the blockchain behind the scenes. If you open up your MetaMask and you go down to, you select the networks and you select add networks, you'll get popped up into a UI that looks like this. If we go back and hit select networks over here, we can actually see information about these different networks. One of the main things that we can see is that all these networks have something called an RPC URL. RPC stands for Remote Procedure Call, and then URL is Uniform Resource Locator. This RPC URL stands for a connection to a blockchain node that somebody is running. This URL connects us to make API calls and to interact with a blockchain node. Blockchain nodes run with software, and some of them expose an API call. If you look at the Go Ethereum website, there actually are instructions for you to run your own blockchain node for a real blockchain like Ethereum. Most of these have flags like -http.adr to expose these RPC endpoints. So if you ever want to run your own node, your own real blockchain node, instead of using MetaMasks or any other of the providers that we're going to go through, you can use Go Ethereum or whatever blockchain you're working with software to run your own nodes. But it's this RPC URL that allows us to connect to Rinkeby if we're on Rinkeby, Ropsten if we're on Ropsten, Mainnet if we're on Mainnet, etc. And it's going to be the way that we're going to connect to our Ganache blockchain that we're running inside of this application. So if you look at the top of your Ganache here, there's a section called the RPC server. And this is the endpoint of our Ganache node right now. So what we can do is we can copy this and go back to our VS Code and paste it in here to see if we can connect. Instead of HTTP with these capitals, we're going to have it be lowercase instead of the uppercase, because the lowercase is more correct and it looks nicer. But now that we have the endpoint, hypothetically with just this, we can start making calls and API calls to this endpoint. You go to this JSON RPC specification, again, link will be in the GitHub repo. We can actually see different calls we can make directly to our node to get different information. ETH get blocked by hash, ETH get blocked by number, and all of these wonderful pieces in here. Making these API calls directly is a little bit annoying to do ourselves. If you want to do it yourself, you absolutely can using an API endpoint like Axios or Fetch. However, we're going to use a wrapper to interact with our node and do things like deploy and interact and other such things with our blockchain node. This is finally where Ethers comes into play. Ethers.js is one of the most popular JavaScript-based tooling kits that allows us to interact with different blockchains. And it has all these wrappers that make all these API calls and do all these things with Ethereum and Polygon and Avalanche and any EVM compatible chain. The other incredibly popular package that does the same thing is going to be web3.js. And you've probably heard about this, and you'll probably see it a little bit more throughout this course and throughout your Web3 journey. The reason that we're using Ethers is that Ethers is the main tool that powers the Hardhat environment, and I really enjoy it myself. And remember, if you ever get lost with any of this, you can always come back to their documentation. To install it, as you can see here, you can just run npm install ethers. We're just going to do yarn add ethers. And now you should see in your package.json, we now have ethers added in here. Awesome. Now back in our code, we're going to import ethers into our deploy.js script so that we can use all the wonderful tools it comes with. So we'll say const ethers equals require ethers. For those of you doing the TypeScript edition of this course, this will be import instead of require. Now that we have ethers in here, we can create our provider object in our main function. The reason we pull ethers outside of the main function is because we do want to pull our package into our script before we call main. We want to make sure all of this is done first. So you'll see this is kind of the normal setup of our scripts. At the top, we import any dependencies or external packages. We'll have our main function, and then we'll call our main function at the bottom. Const is a keyword similar to let. The const keyword makes it so that ethers can't be changed. So we can't change our ethers variable anytime we use const. Require is a function for us to import the ethers package. Now Remix does all this behind the scenes, but the way we're going to do it in our code here is we're going to say const provider equals new ethers.providers.json RPC provider. And then we're going to pass this string as our provider. So we're saying, hey, we're going to connect to this URL right here. Awesome. So this is the way that our script is going to connect to our blockchain, our local blockchain. Now let's get an actual wallet here with a private key and a balance and everything. We can see all of our wallets and private keys in our Ganache here. So the way to get this set up is we can say const wallet equals new ethers.wallet. And this wallet function takes in a couple of input parameters like a private key and a provider. To get a private key, we'll go to Ganache here and just choose one of these private keys. And we're going to paste this right into our code. And then we're going to do comma provider and save that. Now, pasting your private key directly into your code is a huge no-no, and we're going to learn how to avoid this in the future. It's okay right now since we're just using one of the Ganache private keys and you have no risk of having any money associated with this account. These two lines alone give us everything that we need to interact with smart contract. They give us our connection to the blockchain, and they give us a wallet with a private key so we can sign different transactions. If you remember back to our blockchain basics section, this is the private key that we're using to sign all of our transactions, to encrypt our transactions. Now that we have a provider and a wallet, let's go ahead and grab our contract objects from these two files here. In order to deploy our contract, we're going to need the ABI, and we're going to need the binary compiled code of the contract. So we're going to need to read from these two files. To read from these two files, we're going to need to use a package called fs. So back at the top, we're going to do const fs equals require fs extra. I autosave all the time. You'll see, like, I'll do something and then my white dot will go away a lot. It's because my fingers have a habit of pretty much any time I stop typing, I save. So please remember to save early and often. This fs extra should come directly with your node project, but if not, you can always add it with yarn add fs extra. You should see it in our package.json. Now we can get the ABI and the binary. We can say const ABI equals fs.read file sync, which means we're going to synchronously read from this file. We could do it asynchronously, but we want to wait for this file to get done. So we're going to say read file sync. And depending on your VS Code, if you scroll over, you might even get some information about this function pop up like this, which can be really helpful. We can see that we need the path for the file we want to read, and then any options as well. Path of file that we want to read to get the ABI located at /simple storage _sol _ simple storage.abi. And then we're going to do a comma of UTF-8. This UTF-8 is the encoding that we do for this file here. Don't worry too much about what that means for now. So we need the ABI, and we also need the binary, which is in this second file, simple storage _ sol _ simple storage.bin. So we're going to say const binary equals fs.read file sync. We're going to give it the path here, which is going to be / simple storage sol simple storage.bin. And then the encoding option, which again is going to be, and it should look like this. Now that we have the binary, we have the ABI, we can create something called a contract factory, which is not to be confused with the factory pattern. In Ethers, a contract factory is just an object that you can use to deploy contracts. So we're going to say const contract factory equals new ethers.contract factory. And we're going to pass it the ABI, binary, and the wallet. We pass the ABI so that our code knows how to interact with the contract. The binary, obviously, because this is the main compiled code, and our wallet so that we have a private key we can use to sign deploying this contract. Then I usually like to write a little console.log saying something like deploying, please wait. And we can actually deploy this contract with Ethers by doing const contract equals await contract factory dot deploy. Now, this is the first time we've seen this await keyword, and you can only use the await keyword inside of an async function. The reason we want this await keyword, we're telling our code to stop here, wait for contract to deploy. And this await keyword means that this will resolve the promise contract. And this contract factory.deploy with the await here returns a contract object. So now I can do something like console.log contract. Let's see what happens when we run this code. Node deploy.js. We scroll up. We see deploying, please wait. And then we see this massive object that gets printed out. This is the contract object that we just deployed. And in fact, if we go over to our Ganache, we can see that the address that we use for our wallet has a little bit less balance and has a transaction count of 1. If we were working with Truffle, we'd be able to see the contracts here. We're working with Hardhat, so you won't be able to see the contracts in here. But if you go to transactions, we can indeed see the transaction that we just created. This is similar to Etherscan, but for our local blockchain. We can see the sender address, the creation address, the value, gas price, all this stuff associated with this contract. You can also see the different blocks. Since we've only made one transaction, only one block has been mined. And this is awesome. We have all this other stuff associated with it. Great job. You just deployed a contract to your own local blockchain with Ethers.js. This is fantastic. Awesome work. Now, let me show you what happens if we don't use the await keyword here. We're not telling our code to stop. We're saying, hey, deploy this contract and then just keep going. So we never actually check to see if this deploy function finished. So let's see what happens when we run this instead. Instead of that big contract object, we get this promise in its pending state because our code actually finished before our contract could finish deploying. So we see promise pending here instead. This is why the await keyword is so important. We're saying, hey, wait for this to finish. The await keyword also resolves a promise. So it'll wait for the promise to exit its pending state, and then it'll return whatever the pending promise returns. So contract factory.deploy returns a promise that returns a contract. In fact, if we go to the Ethers documentation, we look up deploy in here, we can see contract factory, methods, contract factory.deploy. If we look at the definition of the function, it says contract factory.deploy, takes a whole bunch of arguments and some overrides. This arrow is saying this is what it returns. It returns a promise that resolves to a contract. And that's why we need this await keyword, because contract factory.deploy by itself just returns a promise. But if we do await contract factory.deploy, we're saying it returns a promise that resolves to a contract, and we're waiting for it to finish deploying to resolve to a contract object. So that's going to be a major difference here. Awesome work. So that's going to be why this await keyword is so important. And again, you can only do that in asynchronous functions. So you need this async keyword at the top of your function names. Awesome work. So we've deployed a contract to our Ganache chain. This is fantastic. Let's play with this a little bit more. So what else can we do? Remember how in Remix and in MetaMask, we could add a whole bunch of stuff. We could add a gas limit. We could add some value. When we were doing our transact, we could press the transact button. We know that when we're working with MetaMask and we want to send some money between our accounts, we can actually choose our gas price, our priority fee, all this other stuff. We can actually do all that in Ethers as well. So if we wanted to await contract factory.deploy, but with a certain gas price, we could add these overrides in this deploy function here. Another really neat trick that your Visual Studio Code might have is if you click Command or Control, depending on your setup, you can actually click into a function and see where it's defined and see everything about this function. So if I command clicked, I could see that I'm now in Node Modules, Ethers Project, Contract, Source.ts, all this stuff, and I can see exactly the function definition of this deploy function on the contract factory object, which shows us the same code as what we saw in the documentation. We see we have a deploy function, it takes some arguments, and then it returns this little semicolon means it returns a promise that resolves to a contract, which is really nice. These args in here are actually a list of overrides that we can specify with some brackets. So what we can do is we can put some brackets in our deploy function here and specify certain things. Like for example, we can specify the gas price to being some number. And now if we were to run this, we would deploy this contract with a gas price of this. We could add a gas limit. We can add a whole bunch of different overrides in our deploy function here. Well, what else can we do? Well, we can wait for a certain number of blocks for our contract to finish with. So we've deployed the contract, but maybe we want to wait one block to make sure it actually gets attached to the chain. So we can say const deployment receipt equals await contract.deploy transaction.wait and specify the number of confirmations that we want to actually wait. So we'll wait one block confirmation to make sure that this happened. And then we can do console.log this deployment receipt option. So if we run the code now, we can see all this information about our transaction. And we can see exactly what our transaction looks like. We can see there's 2 is null because we're creating a contract. From is going to be this Ganache address that we got the private key for. We see the contract address that we created, transaction index. We can see gas use, log bloom, block hash, transaction header. We can see all this information about our transaction. Something I want you to take note of is the deployment receipt and the deployment transaction. I want you to separate these two because it's going to make your life a lot easier. So we're going to do a quick console.log. Here is the deployment transaction. And we'll do console.log contract.deploy transaction. And then I'm going to copy this whole line by just typing Command C or Control C right there. And then here is the deployment. Here is the transaction receipt. And then this deployment receipt is the transaction receipt. So I'm just going to rename this to transaction receipt to make it a little bit clear which one's which. And we'll run this one more time. You only get a transaction receipt when you wait for a block confirmation. Otherwise, you're going to get the contract object, which has the deploy transaction with it. This distinction will be more important later on, but I wanted you to know the difference between the two. Transaction receipt is what you get when you wait for a block confirmation. The deployment transaction or the transaction response is what you get just when you create your transaction. So transaction receipt, transaction response, they're different. Receipt is what you get when you wait for a transaction to finish, and then response is just what you initially get. Make sense? Okay, great. I'm going to go ahead and delete those, but those lines will be in the code associated with the GitHub. Now you saw when we actually printed out those receipts, we got all this stuff in here because deploying a contract is actually just sending a transaction, as we've said before. So if we want to see what's really going on under the hood, we can actually create a transaction ourselves and create a contract ourselves just by specifying the transaction information. So how will we do that? Let's deploy this contract again, but only purely using transaction data. So we'll do a console.log. Let's deploy with only transaction data. And this is going to be the way you can actually deploy or send transactions purely with transaction data. You can send any transaction. This gives you unlimited flexibility with the transactions you want to send. What we can do is we can say const or let tx, which is going to stand for our transaction, equals, and we can just add all of our transaction information in here. So the first thing that we're going to need is our nonce, or the number that we only use once. We go back to our transaction count. We're on 4 transactions here. So we'll use the nonce 5 because that's going to be a nonce that we haven't used before. Every time you send a transaction, it comes with one of those nonces, right? So the nonce is a bit of a overused term. We saw it back in our blockchain basics that we use the nonce to solve that hard problem. Nonces are also used in wallets and in signers to send transactions, and they use a different nonce for every transaction. So nonce, when we're talking about wallets, talks about a number associated with a unique transaction. Nonce, when we're talking about blockchain mining, is a value used to solve that hard problem. They both mean the same thing. They both mean a number only used once, but they're different in these different contexts. So we're going to use this number only used once, this unique number for our transaction, to send this. So we're going to say nonce is going to be 5. We're going to pick a gas price of this right here. We're just going to use the gas price of Ganache like that. We're going to pick a gas limit of some big number. We'll use 1, 2, 3, 4, 5, 6. We'll just use that. We're going to say 2 is going to be null, right? Exactly like what we saw in our receipts and responses down here. Since we're creating a contract, value is going to be 0 since we're creating a contract. We don't want to send any ETH or Polygon or Avalanche. And then data is going to be that massive binary object in our binary bit. So in the binary section, we're going to copy this massive binary piece and we're going to put some quotes in here. We're going to do 0x and paste that in here. So this massive data piece is the binary that we're sending. Whenever you send a transaction, you have this data object that you can fill with stuff. We're filling our data object with the binary, with the code that tells Ethereum, that tells our blockchain to deploy our smart contract that's going to look exactly like this. And then finally, we want to add the chain ID. As we've seen before with MetaMask, if we go back over to our networks, each one of these EVM chains has a different chain ID. Ethereum mainnet is 1, Ropsten is 3, Rinkeby is 4, Kovan is 42, etc. And other EVM chains like Avalanche, like Polygon, are going to have their unique chain IDs as well. For Ganache, we can see the network ID up here is 1337. And some people, so we can just paste that in here. Some people have run into some issues where the chain ID and the network ID are different, and the chain ID is actually 31337. So if you have a problem with this, try 31337 instead, but it should be 1337. Now this is a transaction with all this information propagated, which is awesome. However, this transaction isn't signed. So nobody's sending this transaction right now. This is just the transaction details of what somebody wants to do. We actually need to sign this transaction and then send it to our blockchain. Const sign tx response equals await wallet dot sign transaction. And we can pass that tx object, and then we'll do a console.log of the signed tx response. In JavaScript, same as Solidity, if you type 2 backslashes before some code, it won't run that code. So I'm going to go ahead and comment out these 3 lines above. And the way that I'm doing it is by highlighting the sections and hitting Command \, or you might hit Control \, but this is a keyboard shortcut you can use to quickly comment out entire sections. And the reason I'm doing this is because I want to show you what happens when we just run sign tx response wallet.sign transaction. Back in our Ganache, we see that we have 4 blocks in here. So let me ask, if we do this sign transaction and we get this sign transaction response, will we propagate another block? Well, let's find out. We'll run node deploy.js. We get this massive thing here. But if we go back to Ganache, we refresh, we we actually don't see another transaction sent. That's because we're only signing a transaction here. We're not actually sending it. So this signed transaction response, this big number here represents a signed transaction, but not a sent transaction, which is different. We can actually send one of these transactions by changing this line a little bit. So instead of signed TX response, we'll change this to send TX response equals await wallet dot send transaction TX. Then once we send the transaction here, we can do await send transaction response dot wait one. And we're going to wait one block confirmation to make sure this transaction actually goes through. Then we can run node deploy.js, and it looks like it's done, but if we actually scroll up, we actually got an error here. So there's this huge, massive thing here. And if we scroll up, we'll eventually see TX reject error. The TX doesn't have the correct nonce, which, just for some practice, let's go ahead, type this into Google and see what we get. We actually get a Web3.js from 4 years ago. I'm trying to call leaf picked, blah, 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 blah. It looks like this is a MetaMask issue that they ran into. And they said you have to reset your account in MetaMask, which we could do, but let's make this a little bit more specific. Let's say Ethers.js. It looks like we don't get, it looks like as of right now from this recording, we don't get a Stack Exchange ETH or a Stack Overflow question for this. It's probably because this is pretty straightforward. We don't have the correct nonce for our transaction, but this would be a good time to actually make this a question on Stack Overflow or Stack Exchange Ethereum so that it shows up first. So we actually don't get the correct nonce. We're going to want to make this a nonce of 4. You can see here, account has a nonce of 4, TX has a nonce of 5. So we actually would want this to be 4. Now, an easier way to always get the correct nonce here is going to be actually just calling the transaction count from the wallet. So back in the Ethers documentation, there's actually some good samples here on how to signing a message and then how to actually send these messages. So we can do await wallet.get transaction count to get the nonce. So back in our code, we could do const nonce equals await. Oops, I copy pasted it. Await wallet.get transaction count. And then we can just place the nonce right here. Now, let's try running this again. And it looks like this one did indeed go through. We can verify on Ganache here. We do indeed see we're currently on block 5 now, and we have 1 extra transaction. Now we could go ahead and just run this again, and we'll never have to worry about actually updating this nonce ourselves, since we're just calling wallet.get transaction count to keep updating it. Current block is 6, and our additional transaction has indeed gone through. Awesome. I showed you how to actually sign the transaction, but we didn't sign the transaction for our send transaction. Well, why not? If you command click or control click, or you go to the documentation for Ethers, we can see the code for send transaction. So first it does some check provider stuff, does some stuff to populate the transaction, but we can actually see that before it sends the transaction, even in Ethers, it signs the transaction first and then calls this.provider.send transaction. So if you just call send transaction with the transaction details like we did here, it's the same as signing it first and then sending it with the provider. Okay, great. So we've learned how to send a transaction using pure JavaScript and using pure Ethers. One of the main takeaways from this is that every time we change the blockchain, every time we change state, every time we use gas, we're sending a transaction that looks pretty much exactly like this. The data in it is going to be the differentiator. The data for us here was data saying to create a new contract. When we make transactions like adding people or storing, the data that we're going to be passing in our transactions is going to be data associated with calling these functions. And when we actually call functions in Ethers or in Hardhat, we're not going to do this kind of raw const tx and list out all this stuff like here and list out the raw data, right? Because that's really, really hard. Ethers and Hardhat are going to make this process a lot easier. So for now, let's go ahead, comment out this whole section, which again, if we copy this whole thing and then hit command/ or control/ or whatever the shortcut is on your environment, that'll actually comment this out. Let's go ahead and uncomment this section so that we deploy our contract using kind of the Ethers much easier to read way than this weird TX stuff. So cool. So we've changed our script back to deploying our contract like this. Now that we've actually deployed our contract, we can learn how to interact with our contract through code as well. The same way that we clicked these buttons in Remix, we're going to code it out for ourselves here. So if we look at simple storage, We have a button for add person, for store, and then we have these view functions as well. The easiest one is going to be the retrieve function, which grabs our favorite number. Retrieve returns favorite number. So we can call that in ethers by doing const current favorite number equals await contract dot retrieve. The contract object that we have is what's returned from our contract factory as long as we've awaited it. The contract object is going to come with all the functionality described in our ABI. That's why we had to pass the ABI to our contract factory. If we look inside our ABI piece here, we can see it has a ton of information on the different functions that we can call and the types that it has and the return types and everything like that. For example, if I look up retrieve, I can see down here we have retrieve. We can see that the name of this function is going to be retrieve, and the outputs are going to be a uint256 of type uint256. Now, this is a little bit difficult to read because it's not formatted. Since we call this .abi, it's going to be a little bit hard to read, but we could change it, be .json, and then you'll see it's highlighted a little bit. You can even do format document with, prettier, and you'll see it actually formats to be a lot easier to read. Now we can go back to retrieve, and we can see this block of code here defines what the retrieve function can and can't do. I'm going to change it back to ABI, and it looks like my formatting has stayed, which is great. This is much easier to read than it was before. As I said, the ABI, or the application binary interface, is incredibly important for working with our contracts. If we give our code just this huge bytecode thing, it's going to be really hard for any processor to decompile this or understand what the functions are that are going on here. There are decompiler options out there, like ethervm.io/decompile, that can decompile some bytecode into the Solidity, but it can be really tricky to get it exactly right. So it's much easier just to have the ABI to say, hey, this lump of code, this lump of numbers and jarbled nonsense is this. When we deploy this bytecode to the blockchain and we call functions on it, the code will automatically allow those functions to get called if they do exist. But in order for our code to know that they exist, it's much easier just to give it the ABI. So we can get our current favorite number like this. Let's go ahead and console.log the current favorite number. Now that we've edited this code, we're going to, let me zoom out a little bit. Now that we've edited this code, we're going to connect to our Ganache instance. We're going to connect a wallet with a private key that we got from the top of our Ganache here. We're going to grab the ABI and the binary of our contracts and connect them to a new contract factory object, which is connected to that wallet. So that wallet will be the one to actually deploy the contract. We'll deploy the contract with const contract equals await contract factory.deploy. We will wait one block for that transaction to finish. And in fact, we're not going to use transaction receipt. So for now, we're just going to delete that part. We're not going to do any of this here, so I'm going to delete it for now. However, I'll leave this section commented out in the GitHub repo, and then we're going to call contract.retrieve, which should return our current favorite number. Since this is a view function, this contract call won't cost us any gas. If we look at simplestorage.sol, we can see retrieve is a view function. And remember, view and pure functions, if called outside of a contract function call, don't cost any gas. We're just reading off the blockchain. We're not changing any variables on chain. We're not changing the state of the blockchain. So this won't cost any gas. So let's go ahead and run this. Perfect. We get deploying, please wait. And then we get this big number response. So what's this big number response here? Big number is a library that comes with the Ethers application that helps us work with numbers. If you actually scroll down, they even have a section saying, why can't I just use numbers? You'd expect current favorite number to just be 0, but it returns this weird hex thing that says, is big number true? This weird big number thing. So Solidity can't use decimal places, and JavaScript has a hard time with decimal places. And this is kind of the more specific rationale for why not to use numbers. What you'll see a lot of the time, instead of numbers, is you'll see strings like 0. You'll see JavaScript use strings like this, or big numbers. Now, if I were to try to pass a number like this in JavaScript, this number would be too big for JavaScript to understand. So we want to use big numbers or strings when working with ethers. Now we can make this more readable by adding dot to string at the end and printing out the string version of this big number. Now, if I rerun this code, we can see we get 0, which makes sense again, because our favorite number gets initialized to the 0 value if not specified. And we haven't called store yet. So awesome. So that's working perfectly. So this is what our current favorite number is. Let's make this console.log a little bit more syntactical. We're going to use something called string interpolation so we can interpolate our string here with variables. Typically in JavaScript, when working with strings, you use double quotes. However, if you want to mix variables with actual strings, you can use backticks instead. So we're going to use some backticks here, and we're going to say current favorite number, put a colon here. And to tell JavaScript that this is a variable that we want to read, we put a little $sign and a bracket around it like this. Now, if we run this code again, saying deploying, please wait, and we get current favorite number is 0 because JavaScript goes, okay, this is a string. $sign curly brace. Looks like this is going to be some variable or some JavaScript that you want me to interpret, and close it off and then backtick. Cool. So our current favorite number is going to be 0. Great. So let's update on the contract the number by calling the store function. So we'll say const transaction response equals await contract.store, and we'll add 7. Now, since 7's a small number, you can just pass it like 7, but passing it like 7 in a string also works. Again, this is because if we wanted to pass some crazy massive number, JavaScript would get confused. So it's usually best practice to pass variables to contract functions as strings, even though that might be a little bit confusing. Ethers is smart enough to know that this 7 string is actually 7 the number. Then we can do const transaction receipt equals await transaction response dot wait 1. So we'll wait 1 block here. This is similar to us doing contract.deploy transaction.wait. The syntax here is a little bit different than what we saw up here because this is using a contract factory and this is calling a function on a contract. So when we call the function on the contract, we get a transaction response. When we wait for the transaction response to finish, we get a transaction receipt. Now I can do const updated favorite number equals await contract.retrieve, and then console.log updated favorite number is, and we'll do a little string interpolation, updated favorite number, like that. Now let's go ahead and run this. So in this process, what are we doing? We're deploying the contract, we're getting the initial value, we're going to update our contract by calling store, which is going to cost gas. So this is a transaction. We're going to get the transaction response, then we're going to get the transaction receipt. We're not going to do anything with the transaction receipt. I want to ingrain in you all that these two are different, transaction response and transaction receipt, and you'll see why in the future. And then we'll get the updated favorite number, and then we're just going to print it out. So let's do this. Boom, and perfect. Deploying, please wait. Current favorite number is 0. Updated favorite number is 7. And if we go to our Ganache instance, we go to transactions, we can see we now have a contract call at the top. We have the sender, the contract address, the gas price, all this stuff. And we see that our transaction data right here. So this transaction data is what gets sent in that data slot of our transaction object. Ethers is just doing that on the back end for us so that we don't have to make that big transaction object there. All right, awesome. You've successfully deployed a contract to your own local Ganache instance or your own JavaScript virtual machine. This is great. Now let's clean this up a little bit. Because if we look up here, we have both our connection to the blockchain and our private key stored directly in our code. If we were to push this code up to a GitHub or some other code repository, people would be able to see our code. If we look in deploy.js of my code, there's something else in here. We don't actually see the private key or the RPC URL in here. So what's going on? Remember, if you give out your private key, whoever has your private key owns your funds. So even though this is a fake private key that doesn't have any real money in it, we still don't want to have to hard code our private keys into our code just in case we accidentally share code with somebody. So what can we do? Well, one of the most popular methods is actually creating something called a .env file or an environment variable. And if you're familiar with environment variables, you can actually set them right in your terminal, but we're going to set them in our .env. So what you want to do is you're going to want to create a .env file. And this is going to be a file where you store sensitive information. And this is going to be a file. We're never going to share this with anybody. This .env file will stick variables of our choosing into the environment of our code. So for example, if I pull up my terminal here and I do echo cat, this is going to reflect what the cat environment variable is for us. Right now, there is no cat environment variable. However, if I do export cat equals dog, and now I do echo $cat, I get dog output. This is what an environment variable is. It's a variable in our terminal or in our scripting environment. Since I don't want to have to type export private key equals blah, blah, blah every time, what we're going to do instead is we're going to stick them into this .env file. So in this .env, we can put private key equals, and we can grab this private key from our script and paste it in like this. And a note, some tools look for the 0x at the beginning of the private key. Ethers and Hardhat is smart enough that either one works, but if you run into some issues, just know that sometimes you might have to put your 0x at the front of this. Well, great, so now we have a private key in an environment variable. What do we do now? Well, in our deploy.js, we want to grab this environment variable and stick it into our script here so that our script can then stick it into our environment. So we're going to add a tool called .env to make this easier. So we're going to do yarn add .env. And if we look at the .env package, we can read more about it. We can read about how to add it with npm. Again, we're just using yarn add. But then we can just call this require.env.config, and this will pull in all our environment variables. So we can just do require.env.config. We should see this on our package.json. We do. Excellent. Now that we pulled it in, we actually get access to our private key environment variable. You can access environment variables in JavaScript by using process.env. So instead of putting our private key here, we're going to delete that whole thing and substitute it with process.env.private key. And we'll save and it'll reformat for us. To make sure this is actually working, we can just hit up after we save, up a bunch, and go back to node deploy.js. And we see we get the exact same setup. And if we scroll back, you can see a transaction has indeed gone through. If you want to double check that this is actually printing out your private key, we could do console.log process.env.private key, rerun. We see that that is indeed the private key coming from our environment variable here. Awesome. Now our RPC URL here isn't really something that we need to secure. However, maybe we're going to use a certain API key or maybe a certain endpoint that only we want to have access to, and we don't want anybody else to be using our RPC endpoint. So we're going to add this to our .env file as well. So in our .env, I'm going to copy this here. I'm going to say RPC URL equals, I'm going to paste that in there just like that. And we're going to delete here, and we're going to do the exact same thing. Say process.env.rpc URL. And now we're going to run this again, and I'm going to take out that console.log, and we should get the exact same response because all we did was swap out our RPC URL with our environment variable, which is going to be exactly what it was before. So we go ahead and run this, and we get the exact same response. And if we go to Ganache, we see that we do indeed get a transaction here, which is perfect. Awesome. So we've learned how to add environment variables to our .env file so that just in case we want to share our code or we push our code up to GitHub, which we'll do in later sections, we don't accidentally expose our private keys or our RPC URLs. Now, all the code that we have in our project here, if we push it up to GitHub or share it with somebody else, all this code will get pushed up, including our .env file. However, if you look at my code samples here for this course, we don't see a .env file in here. So how is that possible? Well, what we want to do whenever we have a project is create a .git ignore file. And in here, we want to put .env, and we also want to put in node modules. This means that when working with Git and working with version control, which we're going to do a little bit later, we won't push our .env file up to GitHub, and we also won't push up node modules. So if we go back to my example here, we don't see a .env file, but we do see a .env.example just to show you what one would look like. So it doesn't really matter that I have them in here. Now, if you're really paranoid, there's something else you can actually do when running your scripts and running your commands. Let's say you didn't even want to put your private key into a .env file because you were nervous that you would accidentally push it up or something. What you can do is you can add your private key in your RPC URL as environment variables right in the command line. So before you run node deploy.js, what you can do, you can say RPC URL equals, paste your RPC URL, and then you can say private key equals, and then paste your private key, and then do node deploy.js. Setting these right before we run our script is the exact same as if we had set them in a .env here. And if we hit run, we see the exact same output, which means that our RPC URL and our private key went through successfully. This way for key management is fine, but all right, so doing this is going to be much better, but it still makes me a little bit nervous. In our development environments with our fake private keys, having our code in a .env file like this is okay, right? Because we don't really care if this key gets hacked, like nobody's using it. But when we move to a more professional setup, this can be a little bit scary. So how can we make this even more secure? Well, what we can do is actually we can encrypt our private key and store our encrypted key locally. That way, if for some reason somebody does get into our account, our private key isn't just sitting around in plain text. It's encrypted and you'll need to know a password that only you know to get into it. So how do we add that? Well, first, we're going to create a new file called encryptkey.js. And this is some code that we're going to use to actually encrypt a key, and we'll store that locally instead of our private key in plain text. This will make us even more secure so that we don't have our private key just hanging around in plain text here. So let's go ahead and build the script to encrypt our private key. So we're going to use the exact same setup as we did for our deploy script. So we're going to do an async function main. And then down here, I'm just going to go ahead and copy from deploy.js. We're going to use this exact same setup and paste it. Okay, great. We're going to be using ethers.js in our .env again. So we're going to add these in. Const ethers equals require ethers. Const fs equals require fs extra. And then require .env .config. All right, so right now, in our .env, we do have this private key. And again, if you don't want to have the private key in there, what you can just do is you can do private key equals and then, node whatever script you want to run. So we're going to set this script up to run our encrypt key one time, and then we can remove our private key from anywhere in our workspace so that it's no longer in plain text anywhere. So what we want to do is we want to say const wallet, and we're going to create a new wallet, but a little bit differently. We are going to say it equals new ethers.wallet process.env.private key. So we do need our private key to stick in here. But then once we create this wallet, we're going to say const encrypted JSON key equals await ethers.encrypt. This encrypt function is going to return an encrypted JSON key that we can store locally and that we can only decrypt it with the password. And it takes two parameters. It takes a private key password and a private key. So in our .env, just for right now, we're going to create a private key password. And I'm going to say it's password, but obviously this is a terrible password and you should never use password as your password. But for now, we're just going to leave it as password since I'm encrypting this fake key anyways. So we're going to encrypt it by passing the password process.env.private key password. And we're also going to pass the private key. It's not going to be ethers, it's going to be wallet.encrypt. We're also going to pass it process.env.private key. Now let's go ahead and run this right now, and then we'll console.log out this encrypted JSON key and see what happens when we run this. So to run this, we're going to do node encryptkey.js and hit enter. And we'll see what happens when we console log it out. This JSON object here is what our key looks like encrypted. So it's got the address, this ID, version, all this other stuff. And all this other stuff is the encrypted version of this key. If somebody gets into our account and they see this, they'll have to know the password to decrypt this private key. They'll need to know the password to decrypt this JSON object back into a private key. So what we're going to do, now that we've encrypted it, we're going to save it. So we'll do fs.write file sync. We're going to pass it to /.encrypted key.json, comma, encrypted JSON key. So we're saving it to a new file called .encryptedkey.json, and we're passing it this encrypted key that we just made. So if we open up our file explorer and we run this command, you'll see we get a new file called .encryptedkey.json, and it's this encrypted key here, which is awesome. So now what we want to do in our .gitignore is add .encryptedkey.json so that we don't accidentally push this up to GitHub. And now we have an encrypted key, and we can go to our private key and delete this from our .env file. We can also delete our private key password from our .env file so that the password isn't just hanging around in plain text. Now that we have an encrypted key, back in our deploy script, we can change the way that we actually get a wallet. So at the top, we're getting our wallet just by passing in the private key like this. We're not going to do that. We're going to use our encrypted key that we just created. So what we're going to do is we're going to say const encrypted JSON equals fs.read file sync /encrypted key.json, comma, UTF-8. This fs.read file sync is just going to read from our encrypted key.json into this encrypted JSON variable here. Next, we're going to create a wallet from this encrypted key. We're going to say let wallet equals new ethers.wallet dot from encrypted JSON sync, and all these commands that we're working with ethers, we can of course find them in the documentation. From encrypted JSON sync takes the encrypted JSON and a password and returns a wallet object. So we're going to pass it that encrypted JSON that we just read, and then we're going to pass it our password, which we're going to do process.env.private key password. And then finally, the reason I use let here is because now we have to connect this wallet back to our provider. If you look here, we're not connecting our wallet with the provider. When we make our transactions with our contract factory, we need to make sure the wallet knows about the provider here. So we can just say wallet equals await wallet.connect provider. And now if we run our deploy.js with our private key password as an environment variable, it should still deploy. So we can do private key password equals password, which yes, we know is terrible, but that's what we're using for now. Node deploy.js. We should get the same output we've been seeing this whole time. And we do. We're able to no longer have our private key in our .env file, not in plain text anymore. It's in this encrypted key so that just in case somebody hacks our computer, they still won't be able to send any transactions unless they know the password. This is awesome. One more thing to note, if you type history, if somebody got into your computer, a hacker could actually see private key password equals password in your bash history. If you run history -c, you actually will clear your history. Now, if I type history, I can just see that the most recent command I wrote was history. This is really just some of the bare minimum for encryption and keeping your key safe. And it might seem ridiculous that somebody might be able to hack your computer and read your encrypted private keys and everything. But as your projects get bigger and bigger, it is really important to know about private key security and private key safety. And for this course, we're really just giving you the bare minimum here and showing you how to encrypt keys and how to be a little bit safer here. Now, for the rest of this course, we are going to be just using this syntax with our private key in a .env file. The reason why we're doing it like this for the rest of the course is it is a little bit easier. I'm really hoping Hardhat adds some additional features to make private key encryption much safer and also easier to use in the future. And they probably will. And the other reason that we're okay to do this here is because you've solemnly sworn that you're not going to use an account that has any real money in it. For the duration of this course, you're only going to use private keys that have tests on Ethereum or are fake private keys like this one that we got from Ganache. In fact, just to really hone this in the smart contract kit / full blockchain solidity course.js GitHub repo, in the discussions tab, you go to announcements, I've created one called the .env pledge, because recently I've seen too many people follow a tutorial that doesn't tell them about the security risks of doing this. And I've made this .env pledge. I would love everyone to jump on and read. And if you agree, at the bottom, leave a comment saying, I will be safe. I will be safe. Make sure you read and you understand what's going on in here. And I'm not doing this to scare you, because again, at the end of the day, if you use a MetaMask that only has testnet funds for the duration of this course, you will never have to be worried, because if your key gets compromised, it's just testnet. So who cares? This is if you're using a MetaMask or you're working with a MetaMask that has real funds. So I'm going to read out the pledge because it is really important you understand this when you're working with real funds. And if you're like, hey, I'm not working with real funds, I don't care, great, move past this, whatever. But when you do work with real funds, when you do decide, hey, I actually want to deploy this to a real network now, I need real money to do that, come back to this pledge, scroll to the bottom, say, I will be safe, and make sure you read and you understand this. Okay, so the pledge is, I solemnly swear that I will never place a private key or secret phrase or mnemonic in a .env file that is associated with any real funds. Basically, you never have your private key or mnemonic phrase in plain text anywhere. You'll only place private keys in a .env file that only have testnet ETH, Link, or other cryptocurrencies. Because again, if your private key has only testnet funds, then that's great. I don't care. We are aware that if we forget a .gitignore and we push our key phrase to GitHub even for a split second, or even show our key/phrase on the internet, wherever it may be, for a split second, it should be considered compromised and you should remove all funds immediately. So even if you deploy your private key to a website and then immediately delete your website and think, oh, nobody probably got to it, you should consider that private key compromised and you should remove all your funds. And again, this is just for real funds. If your private key with only testnet funds gets compromised, well, who cares? I do that all the time. You've been seeing me do that all the time because it only has testnet funds in it. If at the end of this course you want to steal all of my testnet funds, have a blast. It would be annoying to me at worst. If I am unsure if my account has real funds in it, I will assume it has real funds in it. So if you don't know if it has real funds, assume it has real funds and you will not use it for developing purposes. And then finally, I am aware that even if I hit add account on my MetaMask or other ETH wallet, I will get a new private key, but it will share the same secret phrase/mnemonic of all the other accounts generated in the MetaMask or other ETH wallet. So if I'm in my MetaMask here and I hit create account, I will get a new private key with the new account. However, all of these accounts that I've created with this create account button have the exact same mnemonic phrase or secret phrase. If I import an account with a private key, it's going to have a different mnemonic phrase, but all of the ones that I generate inside that wallet are all going to have the same phrase. Okay, great. Hopefully that'll make sense. I have some pledge additions here. For this course, I will only use funds associated with a brand new, never before used MetaMask or other ETH wallet. Again, this is not to scare you. If you just work with a brand new MetaMask, you don't have to worry about any of this, and just refer back to this when you start looking at real money and real private keys. I'm aware that my account associated with my private key is the same on testnets that it is on mainnets. So like I was showing you, my private key on Rinkeby is going to be the same as my private key on a mainnet. If I must use a private key associated with real funds in the future, until I am 100% sure what I am doing, I will always either use one of the encrypted methods that Patrick showed, use some better encryption stuff that I didn't show, or use the command line way to pass private keys and then delete the command line history right after. If I'm never actually deploying anything to mainnet myself or work with a private key with real funds, I do not need to be concerned. Take a look at this, read this, internalize it. This should make you confident now. Again, I'm not saying this to scare you. I'm saying this to instill confidence in you that these are some of the things that we want to think about. Okay, great. In here, I will be safe. Boom, I will be safe. And if you want to copy paste this on Twitter, put this in a huge tweet thread, go for it. The more people who know about this, the more people who understand the security risks of their .env files and their private keys, the better. So thank you for listening to this. I know I definitely belabored the point, but it is really important. Let's continue with the course. All right, so we're just about done here. However, there's one or two more things we want to do just to clean this all up. Right now, when we're auto-saving, we're using the VS Code plugin for us to auto-format. However, in the future, if anybody else comes across our repository, they might not have the VS Code auto-formatter on. So we want to give users a way to format their code so it matches the styles that we use. So we have Prettier, the extension installed. We can also add Prettier as a Node.js module that can tell other users who don't have a VS Code exactly how to format both their JavaScript and the Solidity. There's a Prettier plugin Solidity located here. There will be a link to it in our GitHub repo. And if we scroll down, we can see how to install it with npm install --save dev, which again, we're just going to use yarn. So we're going to do yarn add Prettier, and then Prettier plugin Solidity. So we're installing both Prettier and the Solidity plugin for Prettier. And if we check our package.jsons, we can see that these two have been added. And what we can do now is we can create a new file called .prettier rc. And in this file, we can define some little curly braces in here. We can define what we want for both our Solidity and for our JavaScript. So for example, our simple storage has a tab width of 4. 1, 2, 3, 4. 4 spaces. Maybe we want to change that. Maybe we want tab width to be 2. So we would save it here. We'd come back to simple storage, save it here, and it would get auto formatted to our .prettier RRC. So in our settings here, we have the default editor for Solidity, our Hardhat Solidity plugin, and the default formatter for JavaScript being the Prettier VS Code one. When we add Prettier RC in here, this file will take precedent over the default configuration, so long as we have downloaded the module in our node modules, which we can see it right here, and we have this .prettier RC file. I'm going to keep the tab with 4, so we're going to update it to that. One thing that we currently do have that I do not like is these semicolons at the end. So we're going to do semi false. And I'm going to save this, come back to deploy, hit save, and you'll see the semicolon automatically goes away. I'm also going to add use tabs false, since I want to use spaces or spacing, and then single quote false. This way we'll always use a double quote instead of a single quote. In JavaScript, you can actually use a single quote or a double quote to define strings, but we're going to make it so that no matter what quote you use, it'll always be double quote. And then for all your open source repos and for all your projects that you make, you'll want to make a readme.md. README files are generally where people put instructions or information about your project or anything like that. This way, whenever anybody comes across your project, they'll know what it's about. Your readme.mds are markdown syntax again. Remember how when we made that trial discussion, we used some interesting tips to format our Solidity and our code here? Well, that formatting process is the exact same for .md files, for Markdown. They're both going to use Markdown. In fact, if we hit Control-Shift-V, you'll enter preview mode for the Markdown. You'll see # here in my preview of the Hardhat. This Ethers Simple Storage FCC is huge and looks like a heading at the top. So Command-Shift-V to view your .md files, or it might be Control-Shift-V for Windows and Linux users. The last thing that we're going to do is we're going to deploy this to a testnet and interact with this on a testnet. We're going to use the Rinkeby testnet, but be sure to use whatever recommended testnet the GitHub repository for this course recommends. Now, looking at our code, you might already have a good idea of how to actually make this slight change. Based off of our last section, we know that all we need is an RPC URL and a private key, and we can begin making transactions on a blockchain. So we're probably going to need a Rinkeby RPC URL and a Rinkeby private key. Where can we find both of those? If you want to do everything on your own and in full decentralized context, we could run a Rinkeby version of Geth. We could run it locally and then just connect to our Geth node. We're not going to be showing how to do this here. However, this is 100% something that you could do. Instead, we're going to use a third-party RPC URL. In the GitHub repo associated with this course, we go to lesson 5. We can scroll down to get a link for Alchemy. Alchemy has a node as a service and allows us to connect to any blockchain that they have support for. Some alternates might be QuickNode, Moralis, or Infura. These all have node as a service options, but we're going to work with Alchemy because it's the one that I like the best. We can go ahead and get started for free or log in or create a new account. I'm going to go ahead and sign up with our Hardhat Free Code Camp user, and we're going to select the Ethereum blockchain ecosystem. Let's go ahead and create our first app. This is going to be, we'll call it Free Code Camp Hardhat. Our app name will be Ethers Simple Storage FCC. And the network is where we're going to choose Rinkeby. But you can see in here, we can actually choose more than just Rinkeby. We can choose Gorilla, Kovan, Rinkeby, Ropsten, and layer 2s like Arbitrum and Optimism. We're going to be using Rinkeby. So let's go ahead and create this app. We're going to choose the free plan. and hit continue. We're going to skip adding payments. If you want to tweet your referral code, feel free to tweet your referral code. We're going to skip for now, and we're going to keep it at capped capacity since we don't have a key in here. And then how did you hear about us? Go ahead and give me that shout out at Patrick and Free Code Camp, and then hit let's go. Now we get to the Alchemy dashboard, where we can see a ton of information about our node and different ways to connect to the nodes and stuff like that. This is going to be really similar to this RPC server endpoint of Ganache, except it's going to be a connection to a real testnet or a real mainnet. What we can do now is we can select our app that we just made, and we can hit view key. And we can see here, we get an API key, we get an HTTP endpoint, and we also get a WebSocket. We're only concerned with the HTTP endpoint. This is going to be our RPCRL that connects to Rinkeby. So what we can do now is we can copy this, we can come over to our Visual Studio Code, and in our .env, we can substitute these out for their actual testnet values. So for RPCRL, we're going to delete this and replace it with our Rinkeby RPCRL. And now, how do we get a private key for an actual testnet that has actual Rinkeby on it? Well, here is where we can use our MetaMasks. So back in your browser, go over to your MetaMask, select the three dots, go to Account Details, Export Private Key, and this is where you can export your private key. Type in your password, and boom, you now have your private key for your account on MetaMask. Now remember, please, please, please don't continue with a MetaMask that has actual money in it. A quick way to check is by going to your Networks tab and seeing if on any of the main nets or the networks with actual money in it, you see any money. I don't have any money in this, so I know I'm good to go. If you have testnet money, that's fine because that's fake money anyways. And again, most browsers have a profile mechanism where you can create a new profile for you to use. But here, now that I've copied my private key, we can come back to our Visual Studio Code, paste the key in here, and now I have a private key that has actual Rinkeby in it. Awesome. And remember, if you ever get low, just come over to faucets.chain.link/Rinkeby. Get some test ETH. I'm not a robot. We'll send the request. Now that we have our private key and our Rinkeby in here, we can now try to run this on an actual testnet. If we look at our code, we see we're grabbing an RPCRL, which is going to be from our .env. We're grabbing a private key, which is going to be from our .env, which points to our Rinkeby MetaMask and our Rinkeby blockchain. So let's just add a console.log under our contract deployment so that we know what address it's at. So we'll do console.log. We'll do some string interpolation. Contract address, contract.address. All right, great. And now let's go ahead and run this. So we'll do node deploy.js. Deploying, please wait. You'll notice this takes a lot longer because we're deploying to a testnet instead of our own fake local blockchain. Testnets and real networks often will take a little bit longer because they need to wait for the blocks to propagate, the transaction to go through, etc. But after a brief delay, we will indeed see that we get a contract address here, and we have a current favorite number. And it's being a little slow again because we're waiting for our next transaction to go through to update the number, and boom, it looks like we've successfully updated it. Now, something that's important to know, if ever you run a command and you want to kill it, you can do Control-C and that will stop it. So any command in the terminal that you want to just abort, Control-C is your get out of jail free card, and that will kill it. That'll stop it wherever it is. So we'll use Control-C a lot in the future. So now let's grab this contract address and go over to Rinkeby Etherscan and paste it in. We can see our two transactions here. We can see we have a contract creation, and we can also see we call a store function. This is awesome. We've successfully deployed a contract to the Rinkeby chain using our own code. Congratulations, this is massive. Now on Etherscan, we actually can verify and publish our contract code. What is verifying and publishing your code? Well, right now, our code looks like a huge jarble of bytecode. And anybody looking at our contract directly on chain will just see this huge jarble of bytecode. We could use a decompiler to try to decompile the bytecode into what it looks like in Solidity, but this can often take a long time and a lot of processing power. So instead, we can just make it much easier by verifying and publishing the code ourselves. If you go ahead and hit verify and publish, we can scroll down and we can add compiler information to compile this on Etherscan and other block explorers. This is a single file. Compiler version is 0.8.7, and its open source license is MIT. Let's go ahead and continue. And we're going to copy paste our Solidity code into this large section. Paste. We don't have any constructor arguments, so we can skip this section. We don't have any libraries or any other miscellaneous settings. So we'll select I'm not a robot. And we'll hit verify and publish. You might have to wait a few minutes, but awesome, our contract was successfully compiled. Now, if we go back to contract source code, we can see all the code in here. And if we grab our contract address, place into the search now, and we go to contract, we get a little green check mark, and we can see anybody can now read our source code. Additionally, those buttons that we saw in Remix for reading from our contract and writing to our contract are in this read contract and this write contract. If we read the contract and we retrieve the most recent number, we do indeed see that we have 7 here because we recently stored 7. Awesome. A quick note, this might already be verified for you since Etherscan might get smart enough to notice that a lot of people are deploying the same bytecode. If it's already verified for you, just go ahead and walk through these steps anyways. Now, the code verification we just did was pretty simple and straightforward because our code was pretty simple and straightforward. Using larger and more complex code can make the verification process a little bit harder. Additionally, we don't always want to have to click buttons on Etherscan to verify our code. We want to do it programmatically. So in later sections, we'll learn how to verify all of our code directly through our code editor. You can imagine the process is this easy for deploying to any EVM chain. In our Alchemy, we could easily create a new app and change our network. And you can see how easy it would be to just switch out this RPC URL and your private key to work on a different chain. This process is also the same for Harmony, Phantom, Avalanche, etc. And if we wanted to switch chains, we would just switch the RPC URL and switch the private key, and everything else would stay exactly the same. Now, Alchemy also shows us and can teach us a lot about transactions and about things that are going on behind the scenes, including a concept called the mempool. To help us understand a little bit more about those transactions that we just sent and how to work with Alchemy to see more about our transactions, we have Albert from the Alchemy team to give us a little demonstration.
Hello, Albert here from Alchemy. I'm at that guy in tech on Twitter. Feel free to follow if you want to engage and ask any questions about this section of the video. But super excited to join Patrick here to explain a little bit of what goes on behind the scenes when you are using Alchemy to submit a transaction. And we have a ton of tools to actually provide a window of visibility into what's going on so that you can actually debug in case there are usage errors on your website or there are pending transactions that are stuck. Whatever it is, we provide that window into the data that you control. Remember that all the transactions that you submit are recorded on the blockchain. They're not controlled by Alchemy. They're not controlled by any other service provider. We are just a window. We're just the plumbing, the piping to be useful to you. So let me show you exactly what that means. Right now, I have a bunch of applications in my dashboard. You can see here that there are different projects that I've used over time. This one is the most recently active, and it is the one that I have currently set up to connect to my MetaMask. So I actually use a custom RPC provider here. And let me make my face a little smaller. And you can see here I've misspelled Rinkeby, but this right now my network is actually connected to the Rinkeby test network via Alchemy. So this is actually this application. So if I click into here in the dashboard, you can see here a bunch of really interesting statistics. This is the first thing that you'll probably use if you're trying to understand more about your application. You'll go here and you can see how many compute units per second your application is currently using. And this is kind of great for specifically Alchemy usage understanding. But then this is also really useful to see, like, what's the median response time? And so 33 milliseconds is pretty good. If that starts to increase, then you might want to figure out, what's going on here. Success rate, it has been kind of low, so that is a clue for me to click on this tab to view recent invalid requests, and that I can actually see, oh, there's a bunch of failed transactions where the transaction has already been sent or the nonce is too low or whatever it is. I can actually use this tab to debug. So that success rate is pretty useful. Throughput, that's been limited. So if you are sending too many requests or your website is getting spammed, you might start getting some requests blocked. So that's what's useful to view there. Concurrent requests over here, success rate in the past 24 hours versus the past 1 hour. The total number of requests in the last 24 hours. And this is different than compute units because each request can have a different level of computing cost. And computing cost is measured by compute units. Total requests is just the actual number of absolute requests. And then, of course, the number of invalid requests. Cool. So one thing I do want to show you that's interesting is when I do submit a transaction, and I actually have one right here that I want to send. So let's transfer between my accounts. And I'm just going to send a tiny amount of Rinkeby ETH, but I'm going to purposefully edit my gas fees to be super, super low so that the node will actually not send the transaction to be mined, or there are no miners that will actually pick it up. So you can see here, I've divided the priority fee and the max fee by a ton. So it's super low. And if I confirm that, in the MetaMask UI, you'll see that the transaction has been pending for a bit. And we'll go over to this mempool tab. This is another really useful visualization. And what the mempool is a kind of a holding ground. I like to think of it as the waiting room of a restaurant, where if you're a transaction and you're waiting to get mined, the mempool is kind of like the waiting room where you're waiting to get seated. So there are different statuses for each of your transactions. The ones that you always want to see are the mined transactions because that says that your transaction is successful and it's now part of the blockchain. Now the mempool, every node has its own holding ground. So I can actually show you this quick visualization. Remember, blockchains are run by a network of nodes, and each node or each computer that's running the Ethereum software maintains a copy of the blockchain. And as a developer, you have to use these nodes to make requests to the blockchain. Now, you can use Alchemy, you can use another RPC provider, you can spin up your own node if you want to. But regardless, you need to use a node to communicate with the chain. Now, each node, beyond having a copy of the entire blockchain state, it also has a local memory of transaction, and that's called mempool. So if there are pending transactions that are waiting to be mined, you can consider them as being in the mempool. Now that's what we're looking at right here. If we click on the app that I am currently using for my MetaMask RPC, then you can see here that there are, oh, this is not the right one. This one is the right one for Rinkeby. For all the transactions here, you can see some were dropped and placed, some were mined, and there's one that's pending. And this pending one actually matches up with the one that is pending here. It's being sent to 0xCBB. And if we click on this transaction hash, you get all the information that you need to debug. So you can see here that it's from my current address, 0xF5F, and then it's to 0xCBB. And here's the value that I'm trying to send. Here's the gas fee that I've attached to this transaction. And you'll notice that that is super low, even for the Rinkeby test network. So knowing this and seeing, wow, this transaction's been pending for 1 minute and 46 seconds. It was sent at this time. I should probably fix that. And so over here, you can actually use the MetaMask RPC, the MetaMask API, and speed it up. And then I'm just going to use the auto high speed up to update the gas fees. And then if we go back to our dashboard, back to our application, you can see that there are some new recent invalid requests. And this is because we've resubmitted a transaction. And then in the recent requests, we have, let's refresh that real quick. You can see that we are sending a raw transaction. This one's already known. And there's another one before, but that's resulting in a get transaction receipt that is successful. And then if we go back to the mempool, you can see, boom, no more pending transactions, only dropped and replaced and mined. So this transaction nonce number 5 is now successful, and you're on your way to developing and maintaining the rest of your application. So yeah, thanks. Hope that was useful. Let me know if you have any questions.
Now, other than the TypeScript portion, which I'll do at the end, you've successfully completed this section. And wow, you've learned a ton. Let's do a quick review of everything that we've learned. Well, first, we've learned how to create new projects with Node.js. We've learned what the node keyword does and how we can use the node keyword to run JavaScript in our local development environment. We learned that we can add different dependencies of external packages into our local package using Yarn or NPM. And we can see those dependencies added in package.json. We know that they've been installed because they get installed into the node modules folder. We can also create a script section where we can minimize long commands that we need to run into a single keyword. Like compile, for example, we can just run yarn compile to compile all of our code. We learned the basic setup of our JavaScript scripts. We import our packages at the top. We have some main executor function at the bottom, and then we have our main function in the middle. We use the async keyword so that our function can use asynchronous programming, and we get access to the await keyword, which basically means, hey, wait for this promise to finish doing its thing. We're able to connect to any blockchain we want using an RPC URL, and then we're able to connect our provider to a wallet or a private key in Ethers by doing something like this. Speaking of which, we've learned about the Ethers package, which is a tool that makes our life a lot easier to interact with the blockchain in JavaScript. If we decide to, we've also learned we can encrypt our private keys so that even if our computers get hacked, our private keys aren't lying around in plain text. And we've learned how to run scripts from our encrypted keys. We've learned how to get the ABI, or the application binary interface, and the binary of our code to deploy to a blockchain. We've learned how to deploy our contracts to a blockchain programmatically, and then we've learned how to interact with our contracts programmatically as well. Additionally, we've learned how to add a default editor in our settings.json of our VS Code, but we've also learned how to override those settings by adding prettier using a .prettier RC file. This way, we can auto-format our code to make it look a lot nicer and much easier to read. Finally, we learned how to deploy one of these contracts to a real testnet or a real network, and then we finally learned the manual way to verify our contract source code. Like I said, we're going to learn a lot of shortcuts and a lot of ways to make this all a little bit easier in coming sections. Whew. You have done phenomenally to reach this section. Give yourself a pat on the back, take a break, go for a lap, and feel really proud about yourself that you made it this far. We've got a lot more to go, but you have come a phenomenally long way. Congratulations. Go take that 5 to 10 minute break and come back when you're ready. Now, the one thing left I want to show you all is the TypeScript edition of this. However, if you're not interested in the TypeScript edition, which you don't have to be, then you're done. There's only a couple of changes we need to make this TypeScript compatible. First, of course, we're going to change our deploy.ts and encrypt key. We're going to change our deploy and our encrypt key from .js to .ts. And then we're also going to swap these requires out for imports. So we're going to import ethers from ethers. We're going to import star as fs from fs extra. And then we're going to import .dmv/config. And then we're just going to copy these and we're going to come over and paste them into here, deleting or commenting out the requires. Okay, great. Now, if we try to run node deploy.ts, we're going to get cannot use import statement outside of a module. In JavaScript, if we'd want to use an import statement outside of a module, we'd come in here and do something like type module like that. But in TypeScript, we actually don't even need that. All we need to do is run this in TypeScript node. So to add TypeScript, we're going to do yarn add TypeScript, and we're also going to add TS node. TS node is the TypeScript edition of node. So now that we've added that, we can try TS node deploy.ts, and we're still going to run into an error. And if you scroll up, we're going to get a couple errors here. We're going to say could not find a declaration file for module fs extra. We need to add the TypeScript version of that. So we're going to do yarn add types /fs extra like that. And if we run it again, it still shouldn't work, but for a different reason. Yes, we're going to get something like this. Type undefined is not assignable to type bytes like. The reason we get this is because process.env private key in TypeScript technically is type string or undefined. So we need to tell TypeScript and the wallet objects and the encrypt function is looking for type string, not string or undefined. So we just need to tell TypeScript that this will not be undefined. So we can just put a bang here and everywhere that we use process.env. Oops, I got to do that on deploy as well. Bang, bang. Looks good. Now that we've added everything in here, if we run ts node deploy.ts, we're going to see the exact same output as we saw with just using regular node. And as long as our private key password is in our .env file, if we run tsnode encryptkey.ts, we're going to get the exact same setup as before, and we're going to get a new encrypted key.json. And that's all you need to do to make this TypeScript compatible. And you should give yourself a huge round of applause for getting this far and learning what's going on underneath Hardhat, the next tool that we're going to learn, and learning all about these transactions and how to interact with these blockchains. This is absolutely massive. So huge congratulations. All right, so now that we've learned about Ethers.js